Hi everyone, welcome to the introduction video of my Raspberry Pi Bootcamp course. Dear friends, I'm Ian Mazalaja. I have been working on programming and electronic boards for 8 years. Also, I have been creating courses on image processing, machine learning, deep learning and game development on Udemy for 2 years. So what we will learn with the course? First of all, we will introduce the Python programming language. Thus, we will be able to control our Raspberry Pi computer with Python. Then we will take a closer look at our Raspberry Pi computer and learn how to use the GPIO pins on Raspberry Pi computer. Moreover, we will learn to use the Raspberry Pi camera by introducing the image processing subject, and we will be able to write image processing codes on the Raspberry Pi computer by making use of the knowledge we have obtained. Finally, we will introduce machine learning and learn how to detect face with Raspberry Pi computer. I can't wait to see you among us already. Let's start without wasting time and learn the Raspberry Pi computer well. In this lesson, we will see how we can install Python to our computer. First, let's open Google and write Python. And let's press Enter. As you can see, Python's official site is available. Now let's open it. And here, as you can see, there is a download section. Let's open it. And here, Python version 3.9.7 is available. Let's download Python. I click Hide, and here, as you can see, it's downloaded. Let's open it. Since I have installed it before, I encountered a screen like this. For this reason, I will choose Customize Installation. And here, as you can see, option of features is here, and I will click Next. And here, as you can see, there is advanced options. I will leave it in a default format. So let's hit the Install button directly. I click Install. As you can see, Python is installing. Let's continue when we are done. As you can see, we have successfully installed Python. Let's click Close. Now, let's write Python in the search section of Windows. I click Search button, and I write here, Python. I click this app, Python 3.9. I'm choosing this, and here now let's write print. And open parentheses and close parentheses, and between parentheses 3 double quotes. And between double quotes, I will write Hello World. And press Enter. As you can see, we have successfully installed Python. In this lesson, we have seen the Python installation. Let's continue with other lessons now. Hi, in this lesson, you can have information about how we can install the PyCharm IDE. PyCharm IDE is an environment that allows us to write our Python codes easily. We will write and run codes in Python lessons through this IDE. So let's get started. First of all, let's type PyCharm into Google and press Enter. I will write PyCharm here. And I press Enter. As you can see, it says Download PyCharm here. Let's click this. And here it is available in paid and free version. We will use free version, so I am using community version because it's free. So let's click community download. I'm choosing the community one. And I click hide. And look, it started. Let's continue when it's done. Alright my friend, downloading is over. Let's click this. And here is the setup screen. As you can see, I click Next. This is the destination folder. Whatever you want, you can use any destination folder. I will choose default. So I click Next. So as you can see, there are some options. I will choose the Create Desktop shortcut and Update Path variable. So I click PyCharm Community Edition and also add bin folder to the path. and then I click next and I click install. It's installing. When it's finished, we will continue. Yes, my friend, the installation is complete. Now we need to restart our computer. I will choose to reboot manually, but you can restart your computer by selecting reboot now. So I click I want to manually reboot later, and I click finish. So let's reboot our computer. Alright, my friend, I rebooted my PC, and as you can see here, there is PyCharm IDE app, and I click this. This is the user agreement. I confirm that, and I click continue. And here, as you can see, this is our PyCharm IDE screen. So let's learn PyCharm IDE. If I click new project button, the PyCharm IDE start a new project. Let's click this. And here, as you can see, there is location section, and this Python project 5 is our project name. If you want to rename your project name, you can change here. For example, I want to change my project name. Let's write here, hello. And as you can see, there is base interpreter. This is very important because we will run our Python code, and this is the part that will run our code. If you want to use all Python versions, you can change here. But if we use Python 3.9, it will be fine for us. So I click Python 3.9.exe. And as you can see here, there is a create button in the lower right corner. Let's click this. So if I click this, my project will be creating. Yes, my friend, as you can see, our project has been created. And here is our project name, which is hello. So let's continue. Let's click close and move to your project folder. And let's right click and move to new and move to Python file. And here we can create our own Python file if we follow these steps. Now let's name our Python file. For example, first project, and press enter. And here, as you can see, our Python file has been created. Now let's come here and write PRINT and open parentheses and close parentheses, and between parentheses write double quote and write here, for example, ilmas. So when we do something like this, we use the standard output function in Python. And if I press the right button of my mouse, and as you can see, here is the option to run it. If I select run first project, my Python file will run. Let's click this. And as you can see here, we run our first code. Yes, my dear friend, we have installed our PyCharm IDE in this lesson. Of course, we are not learning Python at this moment because we are doing the installation process right now. Let's move on to our next lesson and start writing our Python codes. In this lesson, we will learn about variables in Python. Let's get started. What are variables, my dear friend? Variables are containers for storing data values. So, what do I mean? First of all, let's examine the words and numbers here in order to understand better. As you can see, here are the some words and numbers. 5, 1054, eagle, cow, 2021, 1958, Yilmaz, Turkey, Istanbul. I want to a question for you. Can you keep this data in mind? For example, 5, 1054, eagle, cow, 2021, 1958, Yilmaz, Turkey, Istanbul. It will be quite difficult, right? We can keep this data or different data by means of variables. And also, these data can then be used to write your program. And also, their sole purpose is to label and store data in memory. So, in general, the variables are like this. So, how do we create a variable? Let's know about it. Alright, how can we create variables? If we want to create a variable, we have to give it a name. For example, x and 1, numbers, a, and also etc. And of course, we have some rules for creating variables. And let's look at the note. When we create a variable, we must use underscore to separate the variable. So what do I mean? Let's look at the example. First name underscore ID. A variable name created this way is quick. And also it's true. But if I create a variable like this, it will be false, because here the variable is written separately, and also it's false. If I want to separate a variable name, I have to use underscore. If I use underscore, it will be correct usage. So let's look at the second note. A variable cannot start with a number. So what do I mean? For example, 0x. If we use it in this way, we will encounter an error, so it's false. But if I use like this, for example, x0, it will be true, because this is the true usage. Yes, my dear friend, in this lesson we learned about the variables on the slide. Let's learn to use variables practically in our next lesson. In this lesson, we will learn how to create variables in a practical way. First of all, let's create a Python file. Move to your project folder and click Write, and move to New and move to Python file. Let's give it to name our Python file. For example, variables, and press Enter. So, if we want to create a variable, firstly we have to give a name to our variable. For example, let's say x. And secondly, to create a variable, you just assign it to a value and then start using it. Assignment is done with a single equal sign, and I put equal sign. For example, let's assign 5. And if we run program, as you can see, we don't have any error. So this is the true usage. Firstly, we named it, and we use the assignment sign, and also then we assign a value. The value is 5. And now if we come and print this variable with the print function, I press Enter and print, and also open parentheses, and between parentheses I will give my variable name between the parentheses. So I will write here x, and if we do it this way and run our code, let's right click and move to Run Variables and left click. And here, as you can see, we have successfully created our variable. So let's create a different variable right now. I will come here, the first line, I will click left button of my mouse, and I press Enter. And let's create a new variable. For example, we can say y. So let's put the assign sign, and also we have to give a value to our variable. For example, let's say 10. And if we do like this and run our code, move to Run Variables, as you can see, we don't have any error. And if I print y variable 2, so I will say print and open parentheses and give it right here, y variable. So let's run our code. And here, as you can see, we have created 2 variables. We will be successful when we do transactions in this way. Of course, we don't have to create a variable with just numeric values. We can create it in character variable. So now let's create a character variable. Let's come to our source code, click left, press Enter. For example, let's create a variable. I will say name and put assign sign. So if I want to create a character variable, I have to use double quotes, because when I do something like this, my program will understand it as a character. And between double quotes, let's say Yilmaz. And also you can say anything you want. And let's print the name variable. I will say print, open parentheses. Let's enter our variable inside the parentheses. I will say name, and run our program. Move to Run Variables. As you can see, we have successfully created our character variable. Yes, my dear friend, we learned how to create variables in this lesson. Let's continue with our next lesson and learn these subjects better. We do not need to declare variables before using them or take their data type. A variable is created the moment we first assign a value to it. A variable is a name given to a memory location. It is the basic unit of storage in a program. In this lesson, we will talk about variable creation rules. Let's get started. So, firstly, move to the project folder and right-click. Move to New, and let's create a new Python file. I click this, and the name will be, for example, variables underscore rules. And press Enter. Rules for creating variables in Python. The first one, a variable name must start with a letter or the underscore character. So what do I mean? Let's create a variable. I can name this variable with letters or underscores. For example, let's say surname, and put equal sign and also create double quotes and assign to it, for example, Alaja. If I run this program like this, as you see, we don't have any errors, and also we can start with underscore to create a variable. Let's move new line and, for example, put underscore, and let's say, for example, x underscore x. This is the name of variable. So let's put equal sign and, for example, let's assign to value of 10. And if we run our code like this, as you can see, we didn't get any errors in this way either. So let's print these variables. Move to new line and let's write print, open parentheses, and enter the variable names between parentheses. For example, let's say surname. And also move to new line and let's say print here. Print, open parentheses, and enter the other variable name, underscore x. Run the program. As you can see, we don't have any error, so we can create a variable like this. And also, if we want to create a variable, we can start with capital letter. For example, let's move to the new line, and for example, we can say name. The N letter will be capital, so I wrote name, and also put equal sign, and let's assign, for example, Yilmaz. Create double quotes, and I will say Yilmaz. So if I run program like this, as you can see, we didn't receive any errors. So if I move to the new line and let's say print, open parentheses, and also enter the name variable between parentheses, so I will say name, and I will run our code like this. So let's run our code. Move to run variables rules. So I select this. As you can see, we can print successfully. And also we can create variables successfully. Now let's move on to our other rule. A variable name cannot start with a number. For example, I cannot create like 0x or 1234 name or etc. Let's check this out now. For example, let's jump to a new line. Let's try to create a variable named 123id. I will say 123 ID and let's put equal sign and assign, for example, 10. And now let's run our code. As you can see, it gave us an error. It's syntax error, because creating a variable in this way is not allowed. So, if we want to create a variable, we cannot start with numbers. So this operation is wrong. Let's delete this. I'm deleting, and let's run our code again. As you see, we don't have any errors. Now let's move on to our other rule. Variable names are case sensitive. So what do I mean? For example, let's create a variable named k. I will say key, and let's assign to, for example, 10. And move to new line, and let's create a variable named capital key. I will say capital key, and let's assign to, for example, 12. And if I run our code, as you see, we don't have any error. And let's print small key and also capital key. And let's print these letters. I will say print, open parentheses, and let's enter the lowercase letter key here. I will say key, lowercase key, and also move to new line. And I will say print, open parentheses, and let's enter the capital letter key here. I will say capital letter key here. And now, let's run our code. As you can see, when we print these variables, both are different variables. Yes, my dear friend, in this lesson we learn about the rules of creating variables. Let's continue with our next lesson. Just like in mathematics, programming languages like Python, C++, or Java have operators. You will probably already be familiar with these. Since they come from basic mathematics, the arithmetic operators are addition, subtraction, multiplication, division, exponents, fluid division, and modules. The first four are fairly simple. They are addition, subtraction, multiplication, and division, and you will probably already be familiar with them. In this tutorial, we will learn operators in Python. Let's get started. Let's move to the project folder and right-click, New, and we will create a new Python file. Let's select Python file, and let's give a name. For example, I will say operators. And press Enter. If we want to use operators, we need to know their symbols. You probably know them. If we want to add, we must use the plus sign. If you want to subtract, we must choose the minus sign. If you want to divide, we should use the slash sign. And if we want to multiply, we should use the asterisk. So let's create 4 variables. The first one will be value 1. And let's assign to, for example, 20. And press Enter, move to new line. And let's create a different variable, let's say value 2. And assign to, for example, 10. And move to new line. And let's create a value 3. And let's assign to, for example, 2. And move to new line again. Let's say, for example, value 4. And assign to, for example, 18. As you can see, we created 4 different variables. Now, let's do operation on these 4 variables. Our first operation is the addition operation. Let's call our print function, I will say print, and open parentheses, and let's collect 2 variables, for example, value 1 and value 3. I will say in the parentheses, value 1 plus value 3. If I do like this, and if I run our code, as you can see, we have successfully collected 2 different numbers. The first one is 20, and the second one is 2. If I add 2 variables, the result will be 22, and here is the result. So let's continue. This time, let's multiply the value 4 and value 3. Move to new line. Let's say print, open parentheses, and in the parentheses I will say value 4, and I have to use asterisk sign, and also I will say value 3, because we want to multiply value 3 and value 4. And let's run our code. As you can see, when we run our code, we multiply 2 values. The first one is value 4. The second one is value 3. So we have successfully multiplied 2 values. So let's continue with subtraction. Now let's come and subtract value 2 and value 3. Move to new line. I will say print again, open parentheses. In the parentheses, I will say the first one will be value 2. And if I want to subtraction process, I have to use minus sign. So let's put minus sign. And also let's enter the value we want to subtract here. This is value 3. So I will say here, value 3. Now let's run our code. As you can see, we have successfully done the subtraction. So finally, let's do the division. Let's divide value 4 into value 3. Let's move to new line and right here print. Open parentheses. In the parentheses, I will say first value 4. And if I want to do division, I have to use slash sign. So I will put a slash sign. And also I have to enter the second variable. As you remember, it will be value 3. So I will say value 3. And now let's run our code. And as you see, we have successfully division. Alright, my friend, in this lesson, we learned operators in Python. Let's continue with other lesson. In this lesson, we will talk about assignment operators. Let's get started. If you have some programming experience, you will certainly have used assignment operators before. The most used one is equal sign. To use it, simply type the name of the variable you want to assign any value to equal sign and the value you want to be assigned. For example, if we want to assign the value to the variable value, as you can see, we can do the following. Let's create a variable value and put equal sign and assign to 5. And the second step, let's print out variable value. And as you can see, the result will be 5. And also, if you want to decrease the value of variable value with 2, we can use value minus equal sign 2. It's very simple. As you can see, let's create a variable value and put equal sign and assign to 5. At the second step should be like this. Firstly, we have to write our variable name, its value, and we should use minus and also equal sign and assign to 2. If you do like this, the result will be 3 because we subtract 2 from 5 in this operation. And also there are different assignment operators. Let's learn them next to the slides. The other assignment operators work in exactly the same way. These are, as you can see, asterisk and equal sign, minus and equal sign, slash and equal sign. The first one, this is for multiplication. The second one is, this is for subtraction. The third one is, this is for division. If we use these operators, we can simplify our operation. Yes, sir, my friend, in this lesson, we learned assignment operators. Let's continue with other lesson. Comparison operators are used for comparing the values. It either returns true or false according to the condition. In this tutorial, we will learn comparison operators in Python. Let's get started. First, move to the project folder and right-click. Move to New and create new Python file. Let's give a name to our Python file. For example, comparison underscores or P and press enter. Now let's create two variables and compare them. For example, the first one will be A and put equal sign and assign to 12 and move to new line. And let's create a different variable. The name will be B and put equal sign and also assign to, for example, 15. Now let's see each comparison operator one by one. The first one is greater than. This operator returns true if the left variable is greater than the right variable. So what do I mean? As you can see, there are two variables in our source code. And move to a new line and call print function. Open parentheses, and in the parentheses we will compare two variables. For example, if I compare variable A is greater than B, variable B, let's write here A is greater than B. Basically, such an operation is wrong, as you would expect. If we run our code, as you can see, it returns false. Why? Because this operation is wrong. Value 12 is less than 15, so the operation is wrong. As you can see, it returns false. But if we do the opposite, let's move to new line and write here print, open parentheses, and let's say B is greater than A. And now run our code. As you can see, it returns true because the 15 value is greater than 12 value. So the answer is correct. To sum it up, it returns true if our operation is correct. If our operation is wrong, it returns false, as you can see here. So let's continue. The second one is less than. This operator returns true if the left variable is less than the right variable. So what do I mean? Let's move to new line and call the print function. Open parentheses, let's compare variable A and variable B again. But this time we will use less than operator. So right here, the variable A is less than the variable B. Let's run our code. As you can see, the result is true, because the 12 value is less than the 15 value. So this operation is correct. And let's check it the opposite. Let's move to new line, call print function, open parentheses, and this time we will check 15 value is less than 12 value. So right here, value B is less than value A. Let's now run our code. As you can see, the result is false because the 15 value is not less than the A value. So as you can see here, our operation is false. Alright, let's continue it. Equal to operator. This operator returns true if both two variables are equal, if both the left and the right variable are equal to each other. That is, it returns true if both are true. Let's move to new line. In this new line, let's create a variable C and put equal sign and, for example, assign to 12 value. And now move to new line. Let's call our print function, open parentheses, and let's compare two variables. For example, the first one will be the variable A and the variable B. If I write here A is equal to, I have to use two equal sign, is B. Let's run our code. As you can see, the result is false because the variable A is not equal to variable B. So the answer is wrong, as you can see. Let's move to new line. So let's compare the same two values this time. Let's call our print function, open parentheses, and let's say this time variable A is equal to variable C. Now let's check it. Run our code. As you can see, the result is true because the 12th value is equal to the 12th value. As you can see, the answer is correct. Alright, my friend, in this tutorial we learned comparison operators in Python. Let's continue with other lesson. Yes, my dear friend, in this lesson we will learn about standard input and output functions. Thanks to the standard input function, we can get input from the user. Thanks to the standard output function, we can inform the user. So, what do I mean? Let's get started. First of all, let's move to the project folder and right-click. Move to New and create a new Python file. And let's give a name to our Python file. For example, std in out. And press Enter. We have already learned the output function. This is print function. So how can we use it? Firstly, we will say here print, open parentheses, and then create double quotes, and we write what we want to write in it. For example, what is it, and also put a question mark. Let's run our code. As you can see, when we use print function, it gives me an output like this, and it also anything we want to write here. And of course, we can get output other things too. For example, let's move to new line and let's call our print function, open parentheses, and create double quotes. For example, I will write my name and surname in double quotes, Yilmaz Alaja. And let's run our code. As you can see, I got the output successfully. Alright, we learned the print function. So how do we use the input function? Let's learn it. move to the new line. Firstly, we have to create a variable because we need to assign the value we get from user. For example, let's say name. And put equal sign and write here input. And also open and close parentheses and create double quotes. Now we have to give an information to the user in double quotes. For example, press enter your name and also put a colon. Now let's run our codes. As you can see, our program is not ending because the program wants us to enter a data. Let's say here, for example, I will say my own name, Yilmaz, and press enter. As you can see, when we entered a data, the program is over because we wanted only one data to be entered. For example, now let the user enter an input and let's output that input. Let's move to the new line. I will say here, for example, variable x1 and put equal sign and call input function, open parentheses and create double quotes. And let's say, for example, press a number. And also put a colon and move to the new line, and this time we will write here print function and open parentheses and create double quotes. Let's write the value you entered in double quotes. I will say here, the value you entered. And also put a colon. Now we need to enter the variable name in our output function. For this, let's come to the end of two double quotes and put a comma and enter the variable name. Let's come to the end of the double quotes. Put a comma and enter the variable name. What is our variable name? x1. Let's say here, x1. And now let's run our code. As you can see, the program said to us, press enter your name. Firstly, let's say our name, Yilmaz. And now program said to us, press a number. For example, let's say 1 and press enter. And here the program said to us the value you entered, and also the program outputs the value we entered. It's 1. This way we can use our standard inputs and outputs. Alright, my friend, in this lesson we learned about standard output and input function. Let's continue with other lesson. Yes, my dear friend, in this lesson we will learn about lists in Python. So let's get started. List is one of the most frequently used and very versatile data types used in Python. In Python programming language, a list is created by placing all the items inside square brackets separated by commas. It can have any number of items and they may be of different types. For example, float, string, integer, or etc. Now let's move to the project folder and right-click, move to New, and create a new Python file. And let's give a name to our Python file. For example, let's say lists. And press enter. So basically, if we want to create a list, we should give a name to our list. It's like variables. So let's say, for example, values, and put equal, and then we should create square bracket. If we do like this, we can create a list successfully. This is an empty list, you see. If we want to assign a value, we must enter a value inside two square brackets. For example, let's say 12. And if we are going to enter more than one value, we should separate each value with comma. For example, let's say 12 and put a comma. Let's give the second value, for example, 10. Let's put a comma and let's say for this time, for example, 5. And if we run our code like this, as you can see, we didn't get any error. So, and if we output our list on a lim line, let's move to the new line and write here print, open parentheses, and then let's enter the list name here. So as you know, our list name is values. And let's say values here. And run our code. As you can see, we have successfully created our list. And the output is like this. This is a list, so let's continue. Yes, now let's learn how we can access the list elements. So what do I mean? Look at the values list. There are 3 values in this list, so I want to reach the value 10. How can we access this value? So let's learn it. If you want to access the elements of a list, we should use the index operator. So how can we use it? Let's learn about it. Now, let's move to the new line, and let's say here, print function and open parentheses. So if I want to access any value in our list, firstly we have to write our list name. So this is, as you know, values. We should write values. And then we have to open square brackets. Open square brackets. And of course, we need to specify the index number inside our square brackets. So what do I mean? In Python, indices start at 0. So if a list having 3 elements, we'll have an index from 0 to 2. So for example, if we want to reach the value 10 here, we have to go to the first index. So let's write here in square brackets here. We should write here 1. Because the value 10 at the first indices of our list. So let's run our code. As you can see, we have successfully reached the value we wanted. Yes, my dear friend, we entered the list in this lesson. Let's continue with our next lesson. Yes, my dear friend, in this lesson we will learn about tuples. Well, what is tuple? A tuple is a collection of objects which ordered and immutable. Tuples are sequences just like lists. The differences between tuples and lists are the tuples cannot be changed unlike list, and tuples use parentheses, whereas lists use square brackets. So how can we create a tuple? Let's learn about it now. Move to your project folder and let's right-click and move to New, and let's create a new Python file. And let the Python file name be, for example, tuple, and press enter. If you want to define a tuple, we have to create a new variable. So let's write here, for example, numbers, and also put an equal sign, and then open parentheses. Creating a tuple is as simple as putting different comma-separated values. If you want to add any value to our tuple, we have to separate values by using commas. So let's write, for example, 1, 2, 3. And now let's run our code. And as you can see, we didn't get any error. And if we print our numbers variable, so which type is tuple, let's write here print, open parentheses, and let you do our tuple name, so it is numbers. And now let's run our code. As you can see here, we have successfully reached our tuple values. If you want to reach a value in a tuple, we still need to write its indexes, like list. So what do I mean? So let's move to the new line and let's call our print function, open parentheses, and let the give our tuple name, which is numbers. And for example, if we want to reach value 2, we have to enter the index of the value, and the index of this number, the number is 2, is 1. So let's open square brackets and also write 1 here. And now let's run our code again. As you can see here, we have successfully reached the value in the tuple. Alright, my friend, in this lesson we learned how to use tuples in Python. So let's continue with our next lesson. Yes, in this lesson we will talk about conditional structures. First, let's see what the condition is. Conditions allow us to apply or not apply certain situations. So what do I mean? Let's look at the example. Let's talk about our example. Assume that we have a student and the student's grade is prioritized so that he can pass the class. So, as you can see, if the student's grade is greater than 80, the student passed the class. Otherwise, if the student's grades is greater than 50 and also less than 80, the student passed the class responsibly. Otherwise, so that is, if it is not provided in both cases, here and here, that is, if the student's score is less than 50, and if the student's score is less than 50, the student failed in class. And if fitting in this way, all condition is met according to the student's score, and each provided condition has its own cases. And of course, only one of the created conditions will occur. Yes, my dear friend, in this lesson we have introduced conditional structures. Let's continue with our next lesson. Yes, in this lesson, let's see how we can create our conditional structure in Python. Before we started, we will use our comparison operators while using our conditional structures. Let's get started. Let's move to the project folder and right-click, move to New, and let's create a new Python file. And let's say if, and press Enter. Our conditional structures are expressed as if, if-elif, and if-elif-as. If we are going to check one condition, we only need to use the if condition. If we are going to check two cases, it is enough to use if-as condition. And also, if we are going to check more than two cases, we need to use if-elif-as condition. Let's learn how to create a condition now. Let's create a variable, for example. It will be variable x and put equal sign and assign to, for example, 10 value. And press Enter. Now let's check if the variable x is greater or less than 15. So let's create if condition. I will say here if and put a space and also open parentheses. And let's say x is greater than 15, and also put a colon. If you do like this, the condition will be false, because the x value is not greater than 15, so it is false. And if our condition is false, then that condition will not work. So what do I mean? Let's check it out. After put a colon, let's press Enter, and as you can see, it left as much space as the top K. We call this indentation. So let's write here print, open parentheses, and create double quotes. Let's say the condition is false. I'm not entering this condition. So let's run our code. As you can see, our code passed this if block because the condition is false. But if it was opposite, let's check it. I will say x is less than 15. And now let's run our code. As you can see, our program is entering our condition, our if condition. And it prints it like this. The condition is false. I'm not entering this condition. But also, now our condition is true. And let's change this. The condition is true. And also, I'm entering this condition. Let's run our code again. As you can see, it's perfect. Now, let's continue. Let's learn how to create two conditions. Let's learn about it. As you can see, we have successfully created if blocks. So let's press Enter and press Delete button. And here we have to write as, and also put a colon. If we do like this, if the condition is false, our program is going to as block. So let's check it out. Press Enter and write here print, open parentheses, and let's say the condition is false, and put a dot. Now let's run our code. As you can see, it says the condition is true. I am entering this condition. Let's change our x value. Let's say, for example, 20. And now let's run our code again. And as you can see, it says the condition is false because the x value, which is 20, is greater than 15. And when we use if belows, our condition was x is less than 15. So as you know that it's false, so it jumped to the else below. Alright, my friend, in this session we learned about if and also if else condition. Let's continue with our next lesson. Yes, in this session we will continue with the subject of conditional structures. As you know, we learned how to create all conditional structures in our previous 2 lessons. Now let's learn how we can create more than 2 conditional structures. First of all, if we are going to create more than 2, we have to add the if block at the beginning and the else block at the end of the all conditions. And also we need to use elif block as intermediate conditions. So let's get started. Move to the project folder. Let's right click, move to new, and let's create a new Python file. Let's say this time, for example, elif, and press enter. Now let's do an example. Let's ask the user for a number. And if the value entered by the user is equal to the value in our condition, let's enter our conditions and output the value entered by the user. So let's create a new variable. For example, let's say value, and also put an equal sign, and let's use input function. Open parentheses, let's create double quotes, and let's say here, for example, please press a number. And also the colon. After doing this, we need to convert the value we will get from the input function to int data type. So, as you remember, how can we do that? And we have to write here at the beginning of the input function, let's say int, open parentheses, and also at the end of the input function, so here, and also closing parentheses. Now we have to create our condition. Let's create. Move to the new line and let's say first the if statement and put a space and open parentheses and also closing parentheses, and let's say value is equal to, for example, let's say 1, and put a colon and press enter, call the print function, open parentheses, and let's say the value entered by the user, put a colon and also put a comma here because we will also show the variable value. So let's say variable value here. I will say here value. And now we have to move the main block and come to the here, and for this time we have to use elif statement because we are going to create more than 2 conditional structures. So if we want to use 3 or more conditional structures, we have to use elif condition. So let's write here elif and also put a space, open parentheses, and let's say for this time value is equal, for example, let's say 2. And also put a colon and move to the indentation, and let's say here print, open parentheses, and let's create double quotes, and let's say for this time the value entered by the user, put a colon and put a comma, and let's say here value. And also move to the main block, and this time we should use the as block if we are not going to check for any other status. So let's say here s, and also put a colon and press enter, and write here print function, open parentheses, and let's create double quotes, and let's say this time, for example, the value entered by the user is not 1 or 2. Alright, my friend, It looks perfect. Now let's run our code. The program said to us, please press a number, and let's say for example 1. And as you can see, it said that the value entered by the user 1. And as you can see, when we press value 1, the program moved to the if block. And it said to us the value entered by the user, the variable value. And let's run our code again. And this time, let's write here 2 and press enter. And as you can see this time, the program moved to the elif block. And it said to us the value entered by the user is 2. And now let's run our code again. And for example, this time, let's say 52. As you can see, if we don't enter value 1 or value 2, the program moved to the as block. And here it said to us, the value entered by the user is not 1 or 2. As you can see, we did it successfully. Yes, my dear friend, in this lesson, we have learned how we can create more than 2 conditions. So, let's continue with other lesson. In computer programming, loops are used to perform a certain amount of operations. Loops can also repeat themselves indefinitely. In this lesson, we will learn about the for and while loop used in the Python programming language. So let's get started. Move to the project folder and right-click, move to New, and let's create a new Python file. And let's say loops. And press enter. Firstly, let's talk about the for loop. For loops iterate over a given sequence. So what do I mean? Let's create a list. I will say here, for example, for each. And put an equal sign and create square brackets. And let's say, for example, let's create double quotes. Banana. And let's create again a double quotes. And let's say this time, for example, apple. And put a comma. And let's say, for example, this time, orange. As you can see, we have created a list successfully. So why did we create a list? Because the purpose of the for loop is to replace the elements in created list and to perform operations on them. For example, we can print our forest list one after the order. So how can we do that? And let's move to the new line and let's say here for x in for each. And also put a colon. So why did we do like this? Because here we use the basic structure used in Python. Here x is a variable that will replace our elements. So what do I mean? Let's move to the inside of for loop and let's call our print function, open parentheses, and write here variable x. And now let's run our code. As you can see here, our list elements are successfully output one after the other because our variable x here took their place in turn. So here is the result. Only this can be done? Of course no. For example, let's create a list of numbers and add the elements in the list. So let's move to the new line and go to the main block and let's say, for example, numbers. Put equal sign and open square brackets and let's say 1, 2, 3, 4. And now let's sum the elements here. So create any variable. This variable will be total value. And let's say here, for example, total underscores value and assign to 0. Because we will collect all the elements in the loop with this variable. That's why we assigned the value 0. So let's create a new for loop. Let's say here, for example, the variable name will be add in numbers. And move to the inside of for loop. And let's say here, total underscores value. Plus sign and also equal sign adds. If we do it this way, we can successfully sum all the elements in the list. So let's move to the main block, and let's say here, color pin function, open parentheses, and let's create double quotes, and let's say, total, and put a colon, and put a comma, and let's say here, total underscores value. And now let's run our code. As you can see, we have successfully completed the addition all of values inside our list, which name is numbers. So 1 plus 2 is equal to 3, 3 plus 3 is equal to 6, and 6 plus 4 is equal to 10. And as you can see, here is the result. The total value is equal to 10. So we have successfully handled it. Alright, my friend, in this tutorial we talk about loops and also for loop. Let's continue with other lesson. In this lesson, we will learn about how we can use the while loop. Let's get started. Firstly, let's move to the project folder and right-click, move to New, and move to let's create a new Python file. And let's say while here. And also press Enter. While loops repeat as long as a certain Boolean condition is met. So what does this mean? For example, let's come and create a variable here. Let the variable name be a value. Let's say value here. And also put a equal sign and let's assign to it value 10. And then let's come and create the while loop. Let's move to a new line and write while here. And also put a space, and we have to open and close the parentheses. Opening and closing parentheses, and then we need to specify a condition inside these parentheses. And our loop repeats itself until this condition is met. So, for example, as a condition, let's do it from 0 if it is greater than variable value. So, what do I mean? Let's say value is greater than 0. The while loop will work, and to otherwise our while loop will not work. So, let's here put a colon and move to the while loop indentation. And for example, print our variable with print function. Right here, print, open parentheses, and let's say value variable. And also move to a new line. In this new line, reduce value variable by 1 at a time. So let's write here value minus equal sign to 1. If we do like this, our value variable decreases by 1 each time, and this process will continue until the variable is 0, and also 0 is not included. So let's run our code. As you can see, our code runs successfully. So here, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. And also 0 is not included because we only use the greater than sign. So the variable value will not be 0 value. For example, if we use the greater and equal sign here, let's write here greater and also equal sign. Let's run our code again. And as you can see, this time it was 0. Because we change our assignment operator. As you can see, here is the result. Yes, we learned about the while loop in this lesson. Let's continue with our next lesson. Yes, my dear friend, in this lesson we will learn about the break structure. Thanks to the break keyword, we can exit our loops and also we can terminate our code. So how is the break keyword used? Let's get started. Firstly, let's move to our project folder, and then let's create a new Python file here. For example, let's write here break, and also press Enter. And then let's create a new variable here. Our variable will be integer variable. So for example, let's write here, for example, value. And let's assign it to, for example, 0. And also put an equal sign and assign it to 0. And then let's call our while loop. So let's write here while, and the condition of our while loop, for example, let it be value is less than value 10. Our while loop will work. And also let's call our print function and let's get output variable value. So let's write here value and also add 1 to the variable value each time the loop repeats itself. So let's write here value plus and also put an equal sign 1. And now let's run our code. Let's right click and let's run break.py Python file. So now let's run our code. As you can see, our program ran from 0 to 9 and also our program ended. So if I wanted to terminate my code when my value variable is 5, how would I do this? Of course, using break keywords. So how can we use break keywords? Let's learn about it now. Firstly, let's move inside of our while loop below and move a new line. And let's call our if condition here. And then put a space and let's write here our variable value is equal to value 5. And also put a colon. Let's move inside of our if condition and let's break our code. If we do something like this, when my value variable is 5, our code will be over. So let's check this out. Now let's run our code again. And as you can see here, our program ran from 0 to 4. And also our loop is over. So that's why we use the break keyword. Yes, my dear friends, we can use the break keyword in this way. So now let's continue with our next lesson. Yes, my dear friend, we will learn about functions in this lesson. So what is function? Functions take a piece of data, process it, and produce an output. So what do I mean? Let's get started. In programming language, a function is a block of code which only runs when it's called. You can pass data, known as parameters, into a function, and also a function can return data as a result. So how do we create a function in Python? Let's move to the project folder and move to new, and also let's create a new Python file. And let's say here, for example, functions, and press enter. If you want to create a function, we should use div keyword. So how can we use it? We have to write def and also put a space, and we have to define a name to our function. And let's say, for example, hello. And also we have to open parentheses, and also we should put a colon at the end of to our function name. And let's put a colon here and also press enter. My dear friends, we also need to use indentation in function. And as you can see, we have already used indentation. And for example, let's write print in our function. And also open parentheses and let's create double quotes. And let's say, for example, I'm in the function. And also, if we are going to use the operations of a function in the code block, we need to call the function in the main block. So if you want to use the hello function, we have to call the function in the main block. And so let's move to the main block. And let's write here hello. And also open parentheses and let's run our code. And as you can see, the program's output say to us, I'm in the function. So what if we didn't call the function in the main code block? Let's try it. I'm deleting our function. And now let's run our code again. And as you can see, nothing happened. So why? Because when we create a function, nothing will happen if we don't call the function. Alright, now let's go and create a different function. Let's move to the main block. And let's write div keyword and also put a space, and let's say, for example, addition. And also open parentheses. And then put a colon and move to the indentation. See here, we created a function called addition. So if we wanted to add two numbers in this new function we created, how would we do this? Now let's learn how we can do this. For this, I need to enter two different variables inside the parentheses. And let's say inside the parentheses, for example, x, comma, y. When we do something like this, our function requires two different parameters. And now let's move to the indentation, our addition function, and let's write print function here, open parentheses, and let's say x plus y. Look, if we do like this and run our code, nothing happened, as you can see, because we didn't call the addition function in the main code below. So let's call the addition function in the main code below. Let's move to the main below. And let's say here, function name, the name is addition. And also open parentheses, and we have to enter two parameters inside of the parentheses or functions parameters. And let's say here, for example, 4, 2. And now let's run our code again. And as you can see, the function outputs 6. If I change this value, for example, let's say 6. And also now let's run our code again. And as you can see, the function outputs 10. Alright, my friend, in this lesson we have seen how we can create functions. Let's continue with other lesson. Yes, we will continue with the functions. In this lesson, let's talk about default parameters and returnable functions. Firstly, we will talk about default argument. A default argument is an argument that assumes a default value if a value is not provided in the function's call for that argument. If a function requires parameters, it can be of any data type. We require to enter this data. So what do I mean? Let's move to the project folder and move to new, and let's create a new Python file. And also let's say here default underscores arguments and press enter. And now let's create a function. A function name will be, for example, person. With this function, let's define a name, surname, and also age. And let's write def. And also let's give a name to our function. Let the function name be, for example, person, and open parentheses. And let's say name, comma, surname, comma, age. And now also colon. For example, let's come and output out parameters. And let's write print function here, open parentheses. And let's say and also create double quotes. Name is, and move to the end of the double quotes. Let's put a comma. And also let's write name here and put a comma and create double quotes. And let's say this time, for example, surname is, and also move to the end of the double quotes and put a comma. Let's say this time surname, put a comma and create double quotes, and let's say, and also put a space, age is, comma, age. And now let's move to the main block and call our function. Let's say here person, open parentheses, and let's say the name argument let be, for example, Yilmaz. The second argument, so which name is surname, will be, for example, Alaja. The age, for example, 20. And now let's run our code. As you can see, we got the output successfully. Name is Yilmaz, surname is Alaja, age is 20. Well, what would happen if we entered one parameter missing? Let's check this out now. For example, let's delete this age parameter. And also, I'm deleting this. And now, let's run our code again. As you can see, we got to error because we have type error. Person, the function, this is our function, missing one required positional argument. The argument name is age. So as you can see, we got an error because we didn't enter the third parameter. So how do we get past this? Of course, using default arguments. So how can we use it? If we want to create a default arguments, we should assign them to parameters. So what do I mean? For example, as you can see, we didn't enter the third parameter. So let's move to the third parameter in our function. This is age, and put an equal sign, and let's say, for example, -1. If we do like this, and now let's run our code again. As you can see, we didn't get any error, but as you can see, the age variable showed -1. We actually said -1 here because in general a value of -1 corresponds to an error. So here is the result. We got an error in the age arguments. Yes, the default parameter is like this. Now let's learn about returnable function in our next lesson. Yes, my friend, we will continue with functions in Python. In this tutorial, we will learn how we can use return keywords in functions. So, the Python return keyword exists a function and instructs Python continue executing the main program. The return keyword can send a value back to the main program. A value could be a tuple, a string, or any other object. This is useful because it allows us to process data within a function. Then we can return the data to our main program so we can use it outside our function. So what do I mean? Let's get started. Let's move to the project folder and right-click, move to new, and let's create a new Python file. And let's write return here and press enter. And now let's create a function. Let the function name be, for example, value. And let's say def, put a space, value, and also open parentheses, and let's say x, y. As you can see, we define a function called value and stated that two parameters should be entered. Now let's learn how we can use the return key. And let's move inside of our value function and let's write return here and put a space. When we perform an operation in this way, what we need to do is to specify which value the operation function should return. And for example, let's do an addition operation. And let's say here x plus y. And then let's move to the main block and call the function. And for example, let's write value, open parentheses, and let's say, for example, 15, and also, for example, 3. And now let's run our code. As you can see, we didn't receive any output. Because if we are doing something like this, what we need to do is call the print function and copy the function into it. So what do I mean? Let's move at the beginning of our function. And let's say here print open parentheses. And let's move to at the ending of our function. Also close parentheses. And now let's run our code again. And as you can see, we have successfully reached our result. When we did an operation with the function before, the function did not return a value. But as you can see now, it returns a value. We can make the functions return values by doing something like this. Alright, my friend, in this tutorial we learned how we can use return keywords in the functions. Let's continue with other lesson. Yes, In this tutorial, we will learn modules in Python. In Python, modules are simplifiers with the Py extension containing Python code that can be imported inside another Python program. There are a lot of Python modules that we can use today. We will already see the OpenCV module in our next lessons. Modules are Python files that allow us to write the codes we will write more easily and simply. So, how to use a module in Python programming? Let's learn about it now. Let's move to the project folder and right-click, move to New, and let's create a new Python file. And let's say here, for example, modules, and press Enter. When we install Python, many modules come pre-installed. In order to use the modules, we need to use the import keywords. These keywords allows us to use different Python modules on the Python file we are working with. So, how can we use it? Firstly, we have to write import here. And as you can see, the color has changed. And then we have to put a space and we need to enter the module name. Let's use the math module, which is a ready-made module. And let's write here maths, and also press Enter and move to the new line. If we are going to use a function or anything in a module, we must first write the module name. Our module name is math, so we have to write maths here. Here writes maths, and also we have to put a dot. As you can see, there are many structures we can use. For example, let's select pi. If we do like this, we can learn pi number. So, what do I mean? Let's copy math.py, Ctrl+C, and delete it, and also call our function, print function, open parentheses, and inside of our parentheses, let's paste our math.py. And now let's run our code. As you can see here, it gives us the number of pi as output. So what else can we do with the math module? For example, we can do exponential number operations. How can we do this? Let's move to the new line, and also we have to call our print function, open parentheses, and let's say this time math dot POW, and also we have to open parentheses because this is a function and we have to enter two values. Our first parameter is the base number, the second parameter is the exponent, and for example, let's say 2, 3. When we do something like this, it is 2 to the power of 3. Let's run our code again now. And as you can see, 2 to the power of 3 is 8. And here is the result. Yes, my dear friend, we generally use modules in this way. Let's move on to our next lesson and learn how to create our own module. Yes, my dear friend, we will continue with the module topic in this lesson. As you know, we learned how to use modules in our previous lesson. Now let's learn how we can create our own module. Let's get started. Firstly, we have to create two Python files. The first Python file will be the main Python file. The other Python file will be the module file. Let's move to the project folder and move to New, and let's create a new directory. And let the directory name be, for example, problem, and press Enter. And let's move to the problem directory, right-click, move to New, and let's create a new Python file. This Python file will be the main Python file. So let's write main here and press Enter. And now let's move to the problem directory again, and let's right-click, move to New, and let's create a new Python file. And let's say this time, for example, module, and press Enter. As you can see, we have two Python files. The first one is the main Python file. The second one is the module file. And now let's create a function in our module Python file, and then we will use in the main Python file. And now let's say def, put a space, and for example, the function name be addition. And also open parentheses, and inside of the parentheses, let's give two arguments, X, and also Y. And inside of our addition function, let's return X plus Y. As you can see, we have created an addition function. The function will return X plus Y. And we have to run our code. Let's run our code. As you can see, we didn't get any error. And we have to go to the main Python file. So let's move to the main Python file and write import here. And also, we have to write our module name. Our module name is module. And as you can see, we have successfully our module. And now let's press enter. For example, let's create a variable. Let the variable name be add. And now let's call our addition function. So how can we do this? Firstly, we have to write our module name here. Our module name is module. And then we will put a dot. And then we have to write our function name here. The function name is addition. Let's write addition here and then open parentheses, and let's enter two parameters to our function. For example, let's save 5, 6. And now move to the new line and call our print function, open parentheses, and let's output the variable named add now. So write add here and then run our code. As you can see, when we do something like this, we can use the functionals in the module we created. Yes, my friend, in this lesson we have seen how we can create our own module. Let's continue with our other lessons now. Yes, my dear friends, in this lesson we will learn how to install an operating system on our Raspberry Pi computer. For this process, we need to download two different software to our Windows computer. And of course, before using this software, let's insert our SD card into our SD card reader. So here is our SD card reader, and also here is our SD card, and also our SD card is 64 gigabytes, and also this is very enough to create our project or Raspberry Pi. And so now let's insert our SD card to our SD card reader. So like this. And we are done. So now let's plug into our SD card reader to our Windows computer USB port. And we are done. So let's continue with our Windows computer. Especially when we will use a mini computer, we need to format our SD card. For this reason, we need software that can format. The name of this software is SD card for matter. And also let's press enter. And here is our website. The name of this website is sdcard.org. And let's collect this website down. And let's move to the bottom. And here is our download section. And you can also use download for Mac. We will download Windows version because we are using Windows computer. So let's collect for Windows. And let's move to the bottom. And let's click accept. And you see here the download was started. Let's continue when it's over. Alright, my dear friend, we are done. So now let's open our zip file. So here is our zip file. And also let's collect the SD card formatter folder. And let's collect our application. And you see here, the installing was started. Alright, let's click next. Let's accept user license agreement. So let's click next again. And also this is our destination folder. If you want to change destination folder, you can change here. So here. And also I will leave it as default, so that's why I click next here again. Alright, we are done. So now let's click the install button. And also, do not forget to give permission letter. So let's click yes again. And you see here we have successfully installed our SD card formatter software. So let's click the launch the program and also let's click finish. Let's click yes again. And you see here is our interface of SD card formatter. And also if you want to format our SD card, what we have to do now is to select our SD card. So as you can see, here is our SD card name. And also we should click the quick format options and then let's click the format button. And also let's click yes again. And you see here we have successfully formatted our SD card. So now let's continue. So let's close our SD card formatter now. Alright my dear friends, we formatted our SD card in this lesson. So now let's continue with our next lesson and install the operating system on our Raspberry Pi card. Yes, my dear friend, in this lesson we will install the Raspberry Pi operating system on our SD card. We have different ways to do this, and I'm going to show you the simplest form. The first thing we need to do is download a new software. The name of this software is Raspberry Pi Imager. So let's download now. Let's open Google and let's search Raspberry Pi Imager, and also let's press enter. And you see here we have a Raspberry Pi OS web page. So let's click this. And here is our Imager application. And also if you want to use macOS or Linux operating system, you can download here. We are using Windows. That's why I click download for Windows button now. And you see here the downloading was started. And as you can see here, we have successfully downloaded our Imager file. So now let's click this. And also do not forget to give permission letter. So let's click yes now. And you see here is our setup. So let's click install button. Alright, the installing was started. Let's continue when it's over. Alright my dear friend, we are done. So now let's click Run Raspberry Pi Imager. And also, let's click Finish button. And here is the interface of Raspberry Pi Imager. And also, there are two different sections here. The first section is representing our operating system, which want to download operating system. And also, the second one is representing our SD cards. So now, let's select our operating system. So let's select this now. We will use Raspberry Pi OS 32-bit, and by the way, if you want to download 64 bits for Raspberry Pi OS, let's click Raspberry Pi OS Other. And here is our 64-bit. So let's move to the back. And also let's select Raspberry Pi OS 32-bit. Alright, we are done. So now let's select our SD card. So let's click this now. And here is our SD card. So let's select this. And if we click the right button, we will successfully download operating system for our Raspberry Pi SD card. So let's click right button. And also let's click yes. And you see here, the writing process is started. So let's continue when it's over. And by the way, this process may take a while. Feels thought and beat out. Feels from big feels thought and the budget from that feels thought and beat out. Feels thought and the budget come. Come on. Get back to come on. Come on. Pillow soup, pillow seal, son and pillow soup, pillow soup, pillow seal, son and pillow soup, pillow seal, son and pillow soup, pillow soup, pillow seal, son and pillow. Feels fun and then the pattern come down real funny real feels son and PC real sick real son and then the pattern feet fun and DJ come down fun and then fun and DJ come down fun and a little super if you come down fun and then. Yes, my dear friends, our operating system installation process is finished. And you see here, it says it's handled. Now let's come and insert our SD card into our Raspberry Pi computer. So before doing this process, let's close our imager. Alright, so let's do this operation now. Alright, my dear friend, here is the SD card reader and here is the SD card. So now let's take in odds. And also, you see here is the Raspberry Pi computer. And now let's insert our SD cards to the Raspberry Pi computer. If you want to do this operation, the color part looks outside of our Raspberry Pi. So we will insert like this. And we are done. So now let's continue. Yes, my dear friends, in this lesson we installed our operating system on our SD card. So now let's continue with our next lesson and learn more about our Raspberry Pi. Yes, my dear friend, in this lesson we will set up our operating system. Let's get started without wasting any time. First of all, we need a keyboard and mouse to control the Raspberry Pi computer. For this, I will plug in the USB of my wireless keyboard and mouse. So here is our USB. So now let's plug in the USB to our Raspberry Pi computer. So let's plug into USB port. And we are done. Then I will plug my HDMI cable into my Raspberry Pi device for the connection of Raspberry Pi and screen. So here is the HDMI cable. And also, let's plug into our HDMI port. And finally, I need to power our computer. For this process, 5V 3A adapter will be sufficient for this. So now let's plug into our power cable to the Raspberry Pi computer. So here. Alright, we are done. So now let's look at our display. And you see here we got the outputs from Raspberry Pi computer. And also we need to wait 1 or 2 minutes for booting operation. And you see here, we got the output as we want. So here is a setup Raspberry Pi operating system. So now let's focus. Our operating system. And also let's click next. And here is our setting up country. You can choose your country, and also I would choose my country. So my country is Turkey. So I will select Turkey. So here. And also I will select my language, which is Turkish. And also my time zone is Istanbul. So now let's continue. Let's click next. And here is the setting location process. Now we need to create user of Raspberry Pi computer. For this, let's create a username. So for example, let the username be, I will write here Yilmaz. And for example, let the password be, for example, Yilmaz again. And also let's correct this, hide characters. And let's confirm our passwords as Yilmaz again. And we are done. So now let's click next again. And also let's click next again. And now let's connect Wi-Fi. So let's choose your network. So here is my network. And also let's click next. And let's enter password. Alright, my dear friend, we are done. So now let's click next again. And also, this process takes 1 or 2 minutes. Body, let's go. Bite up, bite up, bite up, bite up. Yes, it's taking a long time because it does the necessary updates. That's why we are waiting here. All right, my dear friend, we are done. So now let's click OK. And also we need to reboot our computer. So let's click Restart button now. And also this process for new settings will take effect. Right. Alright, my dear friend, we are done. We have successfully completed our first installation. And by the way, it was really long and boring. You may find our first lessons a bit boring because they are related to the installation. But I'm sure we will have fun together in the following lessons. So now let's move on to our next lesson and learn more about our Raspberry Pi computer. Yes, my dear friends, in this lesson we will learn how to connect to our Raspberry Pi computer remotely. There are some steps we need to do for this. So let's get started. First of all, our way of connecting remotely will be with VNC. Therefore, let's come and open our terminal. So here is our terminal, and let's open this now. And also, I will focus my terminal now. And it looks perfect, and also let's focus more. Alright, and also let's update our Raspberry Pi computer. So for this, let's type sudo apt-get update, and let's press enter. And we are done. And also, if you want to use VNC, we should type in sudo apt-get install real VNC server and put a space and let's type real VNC viewer. And we are done. If you press enter, and you see here our VNC is downloading, and also if you want to continue, let's press yes. And the installation was started. Alright, we are done. So now we need to reach the configuration of Raspberry Pi computer. Because we will set our VNC server it enabled. Because if we do this operation, we can successfully connect our Raspberry Pi computer remotely. So let's do this operation now. So let's try it here. Sudo raspi config. And also let's press enter. And then let's move to the three parts, which is interface options. And here is our VNC. Let's press enter and let's enable it. Alright, we are done. So now, let's move to the back. So if you want to do this operation, let's press the ESC key of the keyboard and let's reboot our computer. So for this, let's write here sudo reboot and let's press enter. Alright, our computer will restart now. Yes, my dear friend, the Raspberry Pi section is here. Now let's make the necessary installation on our device that we will connect remotely. So let's move to our Windows computer. Alright, my dear friends, we are on our computer and now let's come and download VNC Viewer for connection between Raspberry Pi and Windows computer. So for this, let's open Google and let's search VNC Viewer. And also let's press enter. And here is our web page, which is rarevnc.com. And let's click this website. And you see here, there are different operating systems for downloading VNC Viewer. So we are using Windows computer, that's why we should use here Windows. And also, let's click the download VNC Viewer. And here is our attention. We shouldn't keep attention this because this is reliable, so let's click hide. Alright, so now let's open the installation file. And here is our installation file. And also, let's select a language. If we are using a different language, you can select this here. And also, I will continue with English. So let's click OK. And here is our setup. Let's click Next. Let's accept the license agreement. And also, let's click Next again. And let's click Next again. And let's click the Install button. Alright, we have successfully installed VNC Viewer. So now, let's move to the search section of Windows Computer and let's type VNC Viewer. And here is our VNC Viewer. And now, if you want to connect using VNC Viewer, we should learn IP address of Raspberry Pi computer. So for this, let's move to the Raspberry Pi computer again and let's open the terminal. Alright, so now let's open terminal of Raspberry Pi. And also, if you want to learn the IP address of Raspberry Pi computer, let's type sudo ifconfig and let's press enter. And you see here is our Raspberry Pi IP address. So here. So let's zoom now. We will use this IP address for connecting remotely. So now let's move to the Windows computer again. And also your IP address will be different, so that's why you should pay attention this. Alright, my dear friends. So now let's continue. If you want to connect our Raspberry Pi remotely, let's open VNC Viewer and let's move to the file and let's click New Connection. And also we need to enter the VNC server, that is IP address of Raspberry Pi, and as you know, we have already learned our Raspberry Pi IP address. So now let's type this. So my IP address is 192.168.1.39. And also let's click OK. And let's click the IP address. Alright, we have successfully connected our Raspberry Pi computer, and also they want to give us to username and password. And as you know, my Raspberry Pi computer username is Yilmaz and password is Yilmaz. And also let's click the remember password and also let's click OK. Alright, you see here is the result. We have successfully connected our Raspberry Pi computer remotely. For example, let's close our terminal. And you see here, we are controlling Raspberry Pi computer remotely. Yes, my dear friend, in this lesson we learned how to connect to our Raspberry Pi computer remotely. So now let's continue with our other lessons. Yes, my dear friend, in this lesson we will set up the environment necessary for us to write our Python codes. The IDE we will be using is Visual Studio Code. So, let's get started. If you want to do this operation, first let's connect our Raspberry Pi computer. For this, let's open VNC Viewer. And as you know, we have already learned how to connect our Raspberry Pi computer remotely. And here is our IP address. So now let's open this IP address. Alright, we are done. So now let's learn how can we download Visual Studio Code in Raspberry Pi computer. First of all, let's open Terminal and let's write some commands to the terminal. So let's type sudo apt install code and also let's press enter. And you see here, our downloading was started, and let's continue when it's over. Alright, my dear friend, we are done. You see here, our downloading operation is done. So now let's check our Visual Studio Code. So let's close Terminal. And also let's move to the Raspberry Pi menu. And let's move to the Programming. And you see here is our Visual Studio Code IDE. So now let's collect this. And here is the result. So if we want to write our Python codes on the Visual Studio Code IDE, we need to do some operation. So let's close Get Started section. And also let's move to the Explorer and let's click Open Folder. And let's create a new folder here. And let the folder name be, for example, Raspberry Pi Projects. And also let's click Create button. And then let's click Open. And also let's click the Yes, I trust the authors. And we are done. Alright, so now let's write our Python codes. For this operation, first let's move to the extensions. And also let's type Python here. And here is our Python extensions. This is for coding Python. And also, if you want to write our Python codes using Visual Studio Code IDE, we should click the Install button here. And you see here our extension is installing. So now let's continue when it's over. I get body less. Wait up, wait up, wait do do. Wait up, wait up. Focus on make clear food. Wait up, I want. Strong, big heart, every bone with every arm, every fun, big arm, every bone. That flows with the swing of the big arm. Say this all, it's a lot of fun. People slow, go on, big arm. It's getting slow, go on. Alright, my dear friend, you see here we have successfully installed Python extension for Visual Studio Code IDE. So now let's check our process. For this, let's move to the Explorer section again, and here is the button. The button is representing to create a new file. And let's collect this, and for example, let the Python file name be test. And also we need to add Python extension of our file. And as you know, this is .py. And if you click enter, and you see here we have successfully created our Python file. For example, let's print hello world. And also, let's close this file now. And if you want to check our code, first we should save our files. If we want to do this operation, we should use Ctrl and S key. And also, let's click right. And you see here, it said to us from Python file in terminal. So now let's collect this. Alright, we got an error. Yes, we wrong our print function name. So let's delete the letter T. And if we run our code again, and you see here we got to output successfully. Alright, my dear friend, in this lesson we learned how to install Visual Studio Code IDE to the Raspberry Pi computer. So now let's move on to our next lesson and learn more about Raspberry Pi computer. Yes, my dear friend, in this lesson we will learn about breadboard. So let's get started. So here is our breadboard. So now let's open the box. Let's take it out. Alright. It is the tool where we test our circuits on the breadboard. It allows us to easily test the circuits we have built without soldering them to each other. And also, it allows us to test the circuits we have designed before transferring them to printed circuit boards or perforated plates. In this way, we can check the circuit connections and observe if there is an error. Since we can install the circuit as plugin, it gives us the opportunity to reuse the electronic components we use in other projects. The internal structure of the breadboard consists of metal clamps positioned vertically and horizontally connected to each other. Let me look from all sides, the reds, so here and here, and also blue parts, so here and here, that we see here are the rows of the breadboards. These parts are in conduction in the form of a line from one end to the other. For example, let's think about our blue part. It starts from here, and also it's ending from here. And also the same as the red one. So the red one is starting from here and ending from here. And by the way, we can see these parts on both sides of the breadboard. So here and also here. The points we need to pay attention to here is that this line is split in the middle on some breadboards. So these are split from the middle part. So it is not a short circuit from start to finish, because the middle parts is a short line, but top and bottom line are long. And by the way, the middle parts of the breadboard also consist of conductors placed into column. These parts are both sides of the breadboard, so here and here. Just like the rows, all of these conductors are covered with a plastic that consists of hose rails for us to place the feet of the electronic components. So now let's focus our breadboard. And you see here, there are a lot of columns on the breadboard, and you see here each column short circuit with each other. So let's look at the first line of the breadboard. So here to here is the short circuit. And let's look at another one. So here and here is a short circuit. That's why we need to pay attention too. Alright, my dear friend, in this lesson we learned about breadboard. So now let's move on to our next lesson and let's build our circuit using Raspberry Pi computer. Yes, my dear friends, in this lesson we will examine the breadboard more closely. As you can see here, I have a LED light. So here is our LED, and let's use this LED light on the breadboard. If you want to do this operation, we need to learn about LED. You see here we have two legs of LED, and this one is long leg. So let's focus now. This one is long and this one is short line. And also the long leg represents the positive line and the short leg represents the negative line. So here is the negative and here is the positive. If we are going to use the LED on a breadboard, we shouldn't connect the legs of the LED vertically. So what do I mean? Before we start, do you see here we have a power supply? And also our voltage is equal to 2.4. And also do not forget to decrease voltage from 3.3. And also if it is higher than 3.3 voltage, our LED will be burning. So that's why we need to pay attention too. So now let's focus our breadboard. Alright. So here is our LED. We shouldn't connect our LED legs like this. If we use the same column of the breadboard for connecting LED, we will get an error because this is a short circuit. That's why we need to pay attention too. And also, if we want to use LED with the breadboard, we should connect our LED legs different columns. For example, like this. So here is our positive line. And for example, let the positive line column be first. And let the negative line be, for example, column 3. So here is our column 3. And you see here, we are done. And now, if you want to turn on the LED, we should give power to our LED. And you see here, this is our positive line, and this is our negative line. Alright, so now let's connect our positive power line to our lump line. So here is our lump line, which is first column, and here is our short line. And you see here we have successfully turned on the LED. So we are done. For example, let's use different column of the breadboard. For example, let's take it out to negative line of the breadboard. For example, let's plug into the 10th column. And you see here we have one more jumper cable. And now let's connect our jumper cable between the short leg of the LED and the 10th column. And you see here, we got the same result. So here is the result. Alright, my dear friend, in this lesson we learned more about breadboard. So now let's move on to our next lesson and learn the GPIO for Raspberry Pi. Yes, my dear friend, in this lesson we will have information about the pins of our Raspberry Pi computer. As you can see on the Raspberry Pi computer, the pin layout is like this. So here is our pin layout. And generally we use the GPIO pins, so here for example, and here, where we want to control a LED or motor or send a signal. In this way, we can control the electronic components as we want. And the electronic parts we will use, as you know, even needs it. We do this with GND, that is ground pins. We can also control the screen with the Raspberry Pi computer. For this, we need to take advantage of special GPIO pins. These are the lines that support I2C or SPI. So here is our I2C. For example, in this lesson, we will learn how to control LED using Raspberry Pi computer. We will use GPIO pin 17 for this. So here is our 17 GPIO pins. And of course, the positive line of our LED will be connected to line 17. And also the negative line that we will connect to the GND line, which is ground line. After a short briefing, let's learn how we can control the LED. So, let's get started. Alright, my dear friend, in this lesson we will learn how to control LED using Raspberry Pi computer. And also, if we want to do this operation, we need some materials. The first one is breadboard. And the second one is two jumper cable, which is female to male. And lastly, we need a LED. If we have all of the materials, we can successfully control the LED using Raspberry Pi computer. So let's do this operation now. So now let's plug in our LED to the breadboard. So the left side is our positive line and the right side is our negative line. So now let's connect our LED to the breadboard. And you see here, we are done. And also, let's plug in our jumper cable into the breadboard. And also the pin cable is representing our positive line. That's why I plug into the here. And also, the blue one is representing negative line. So, which is ground. Alright, so now let's connect these two cables to the Raspberry Pi computer. If we want to do this operation, first let's start with blue cable. The negative line is representing GND line, which is ground line. That's why we should use the ground line of the Raspberry Pi computer. And also this is the third one. So here is 1, here is 2, and here is third. So now let's plug into the Raspberry Pi computer. And also this is our positive line, and also if we want to use positive line of the Raspberry Pi computer, and also if we want to use any control device using Raspberry Pi computer, we should use the GPIO pin. I will use the 17 GPIO pin, that's why I plug into the 6th port of Raspberry Pi computer. So when we look at more closer, this is first, this is second, this is third, fourth, fifth, and sixth. Alright. And you see here, we have successfully connected our LED to the Raspberry Pi computer. So now let's move to the Raspberry Pi computer and let's write in Python codes for turning on LED. Alright, my dear friends, so now let's connect to the Raspberry Pi computer. For this, let's open VNC Viewer. And here is our IP address, so now let's connect this. And we have successfully connected to our Raspberry Pi computer. And as you know, we will write the Python codes on the Visual Studio Code IDE. So now let's open the Visual Studio Code IDE. We can do this 2 different ways. The first one is move to the Raspberry Pi menu, and let's go to Programming, and let's open the Visual Studio Code IDE. We can do this and also we can open the terminal, and if we type here code, and if we press enter, and you see here, the Visual Studio Code IDE opened. So now let's continue. If you want to control the LED, let's move to our project folder and let's create a new Python file here. For example, let the Python file name be controlling _ LED.py. And also let's press enter. And now let's close the test.py Python file. And let's continue. First of all, we need to import the library necessary to control the GPIO pins. The name of this library is import GPIO 0. And also, let's move to a new line. And now, we will define our LED GPIO pin number. And also, if we want to do this operation, what we have to do now is to create a new variable here. Let the variable name be, for example, LED1. And also put an equal sign. And if we want to control the LED, we should learn a new class here. The name of this class is LED. So now let's call the LED class. For this, first let's call here our module name, GPIO0. LED, and also open and close parentheses. In the parentheses, we will enter one parameter here. The parameter represents pin number, and as you know, our GPIO pin number is 17. That's why I entered here value 17. So we are done. And then let's move to a new line. For example, let's turning on the LED. For this, we should use on method. So what do I mean? First, let's call here our variable, which is LED1, and put that out. And you see here, if I write here on and open and close parentheses, our LED will be turning on. But by the way, it will be turning on and then it will be turning off quickly. So why? I will tell you this, but first let's test our code like this. So before run our codes, I will show you my LED to you. And if we run our codes, and you see here, our LED is turned on, and then our LED is turned off quickly, because we didn't give any waiting time for our LED. So now let's give some delays to our LED. For this, we should import a new module here. The name of this module is time module. For this, let's move to the top and let's import our time module. And also, let's move to the bottom again. And in the time module, we will use a new function here. The name of this function is sleep. So let's call here time.sleep. And also open and close parentheses. In the parentheses, we will enter one parameter, and also our parameter is representing delay for seconds. For example, if I enter value 1 here, our LED will be turning on for 1 second. For example, let's check our code now. So let's save our Python file and let's run our codes. And you see here our LED was turning on for 1 second. For example, if I enter the value 5 here, and if we run our code, and you see here, it's turning on for 5 seconds. So that's why we need to pay attention to, and that's why we need to import our time module. Yes, my dear friends, in this lesson we learned about LED control. So now let's continue with our other lessons. Yes, my dear friend, in this lesson we will develop our first example together with you. With the example we will do the blinking process with our LED according to the number we will enter. So, what do I mean? We will ask the user for a number and also with the input function, and we will turn on and off the light of our LED as much as the number to be entered. So, let's do this operation now. So now let's connect to our Raspberry Pi computer. For this, let's open the VNC River. And here is our IP address. So now let's connect. And we have successfully connected to our Raspberry Pi computer. And open the terminal. And let's type codes and let's press enter. Alright. So now, let's close this file. And also, let's move to our project folder and let's create a new Python file here. Let the Python file name be, for example, example1 dots py. And also, let's press enter. As you know, if you want to control the LED, we should import a new module here. The name of this module, as you know, GPIO0. So, as you know, we will use the LED class from our module, which is GPIO0. For this reason, let's import our GPIO0 library. And also, let's mutate new line, and in this new line, we will import one more module here. As you know, we will do blinking operation right, and blinking operation represent turning on the LED and turning off the LED using reaction time. So that's why we should import time module. And also let's mutate new line, and in this new line let's define our LED. We will use the same pin number previous lesson. So for this, let's create a new variable here. Let the variable name be, for example, LED1. And put an equal sign, and let's call here GPIO0 dot LED class. And also open and close parentheses, and in the parentheses let's define our pin number. As you know, our pin number is equal to 17, but also we can define a different way our pin number. So what do I mean? For this, let's delete the 17 here, and let's move to the top. And let's create a new variable here. Let the variable name be, for example, pin underscore number of LED. And let's assign value 17. And if we define this variable in the LED class, so let's define as pin underscore number of LED, we didn't get any error. This is the same way using pin number. So let's continue and let's move to a new line, and in this new line we will get the value from the user. And also the value will be integer value. That's why we need to convert our input function as integer variable type. So for this, for example, let the variable name be value, and also put an equal sign, and let's convert integer variable type, and let's quote here our input function and open and close parentheses, and for example enter value and put a colon, and let's move to a new line. And also we need to create one more variable here. The one more variable represent value 0, because if I answer value 5 to the value variable, our blinking operation for the LED will be 5 times. So that's why we should create a new variable here. Let the variable name be, for example, starting, and let's assign value 0. And now we should create a loop here, because with this loop we will do blinking operation how many times we want. So for this, let's create a while loop here. And also we will check if our starting value is less than our value. Let's move inside of our while loop. And also, if you want to do blinking operation first, let's turn on the LED. And as you know, if you want to do this operation, let's call here LED1 variable. And let's use on methods. And also let's move to a new line. And in the new line, let's give some reaction time for blinking operation. And as you know, for this we will use time module. So let's call here time.sleep. And open and close parentheses, and also our blinking operation needs 1 second. That's why I entered value 1 here. And then let's move to a new line, and this time we should turn off the LED. So for this, let's call here LED1 dot, and we will learn a new method here. The name of this method off. If we do something like this, our LED will be turning off. And also we need to give some reaction time again. And let's quote here time.sleep. And open and close parentheses. And let's define value 1 here again. And finally we have one more step. We will decrease our variable value as 1. So why? Because we will do blinking as many times as we will enter. That's why we should decrease our variable value. So now let's decrease our value variable as value 1, and we are done. So now let's test our code. If you run our code like this, and also I will show you my webcam. So I will open my webcam. And also let's run our codes. And you see here, our program wants us to give a value. For example, if I enter value 5, and let's press enter, and you see here 1, 2, 3, 4, and 5 times our LED was turning on and also turning off. So we are done. For example, let's check our code again. And this time, for example, let's do 10 times for blinking operation. Alright, let's take this and let's enter value 10 and let's press enter. And you see 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Alright, it looks perfect. Yes, my dear friends, in this lesson we have developed our first example. So now let's move on to our next lesson and let's learn more about GPIO topic. Yes, my dear friend, in this lesson we will learn about use of buttons with Raspberry Pi computer. So, what is a button? So here is the button. A button is a simple toggle mechanism that, when pushed, initiates and controls a process in a machine or software. The adjacent pins of the button do not come into contact with each other. It has to be pressed to make contact. If pressed, it touches and returns true to us with the software. And also, the button is very easy to use with the Raspberry Pi computer. So, let's find out how we can use it. First of all, let's learn about our materials. If we want to use buttons with Raspberry Pi computer, first we need a button and we need a breadboard. And also we need two jumpers, which is male to female. And also we need a Raspberry Pi computer. So now, let's plug into our button to the breadboard. So like this. And also we will connect our jumper cables to this and this line, because when we press the button, it will be contact with the cables, and also it will return us to audio true. And the other hand, we can also use a different line of the button, for example, like this and like this. So now, let's plug into our jumper cables to the bottom pins. And you see here, one of our cables here will be connected to our GPIO pin and the other to our GND pin. For example, let's connect our blue cable to the GND line of the Raspberry Pi computer. So here is our GND line, and also let's connect our pin cable to the GPIO pin, and also we can use any GPIO pin for using button. For example, let's use GPIO 3 pin. Let's look at more closer now. And here is our 3.3 pin, and here is our GPIO 2. Then the third one of the blue parts opposites is GPIO 3 pin. So now let's plug into our pin cable to the GPIO 3 pin. So like this. Alright, we are done. So now let's move to the Raspberry Pi computer and let's learn how to control button with Raspberry Pi computer. Alright, my dear friends, so now let's connect to the Raspberry Pi computer. So here is our IP address, so now let's connect this. And also open the terminal, and let's type port, and let's press enter. Alright, so now let's move to our project folder and let's create a new Python file. Here, let the Python file name be, for example, tests button and .py. Let's press enter. And as you know, if we want to control our GPIO pin using Raspberry Pi computer, we should import GPIO 0 module. So let's import GPIO 0. And also let's mutate new line and let's create a new variable. Here let the variable name be, for example, button, and put an equal sign. And now if we want to use button using Raspberry Pi computer, we should call here a new class. And also we will learn a new class here. The name of this class is button. With this class, we can successfully control the button, and also when we control the button, we can control any device that we want. So now let's call our button class. For this, first let's call here our module, GPIO 0 dot, and also let's call button class and open and close parentheses. In the parentheses, we will define pin number here, and as you know, our pin number is 3. That's why I entered value 3 here. And also let's mutate a new line. If we run our code like this, and you see here we didn't get any error. And if you want to check if the button has been pressed, what you have to do is learn a new method. The name of this method is wait for press. So now if we want to call this method, first let's call our button variable and let's put a dot and let's call wait underscore for underscore press. And also open and close parentheses, and for example, if I press the button, let's print I pressed the button and put a dot. Alright, so now if we check our code, I will save my Python file now, and let's run our codes. And you see here, our codes didn't finish because I didn't press the button. If I press the button, so I will press right now. And you see here, we got the output as I pressed the button because these methods returning us true. When it returned us true, we got the output like this. And also you can ask me, does it really give us a true value? And also we can check this now. So for this, let's delete print function. And also let's use these methods in the print function. So now let's move to the beginning of our button and let's call print function here. And if we run our code like this, and also, if I press the button, we will get the result as true. So I will press right now. And you see here, we got the output as true. So it looks perfect. Alright, my dear friend, in this lesson we learned how to use button using Raspberry Pi computer. So now let's move on to our next lesson and let's do different example using button and also LED. Yes, my dear friends, we will develop our second example in the session. With the example we will press the button, and when we press it, our LED will turn on, and when we press it again, it will turn off. And when we finally press it again, our LED will turn on again. That is, we will perform an example that repeats this process 3 times. Before we start coding, let's come and create our circuit. For this example, we need some materials. The first one is a button, and the second one is a breadboard, and the third one is LED, and also, finally, we need some jumper cables. Here is our male-to-male, and these are female-to-male jumper cables. So now let's build our circuits. For this operation, we will use the negative line on the breadboard, so our LED ground line will connect with our negative line on the breadboard. And also we can use any line for positive line of our LED For example, let's use the fourth column of the breadboard. And also let's plug into our button to the breadboard. And we are done. So now I want to inform you about something. Our LED ground line will be the same as our bottom ground line. That's why the cable it will connect between our LED ground line, so which is negative, and also our bottom ground line. And also, we will connect all of the ground line to the Raspberry Pi computer JND line. So I will use blue cable for this operation, and also let's connect our cable to the Raspberry Pi computer JND line. So which is the third one? Alright, we are done. So now let's connect our GPIO pins for button and also our LED. For button, I will use the second GPIO pin. For this, I will connect my button to the second GPIO pin. And also for the LED, I will connect the positive line of the LED to the fourth GPIO pin of the Raspberry Pi computer. Let's focus more closer now. So, this is the first, this is the second, this is the third, and this is the fourth one. And also, this is our fourth GPIO pin of Raspberry Pi computer. So now, let's plug into our LED positive line to the fourth GPIO pin. Alright, my dear friend, we are done. So now, let's move to the Raspberry Pi computer and let's coding this example. Yes, my dear friends, let's start writing our codes. Let's open VNC Viewer now and let's connect to our Raspberry Pi computer. So here is our IP address, so now let's connect this. And now let's open Visual Studio Code IDE. Let's move to the Raspberry Pi menu and let's move to the programming and let's open the Visual Studio Code. And you see here is our project folder, and also let's create a new Python file in the folder. So for this, let's click New File button, and let the new file name be example2.py, and also let's press Enter. Alright, so now let's write our code. If you want to build our example, as you know, we should control our GPIO pin of the Raspberry Pi computer. For this, we should import GPIO 0 module. So let's call here GPIO 0. And also, we will give some reaction time. That's why we should import time module. And also, let's move to a new line. So now, let's define our bottom pin and also our LED pin. For this, we will create two different variables here. Let the first variable name be, for example, button1. And let's call our button class in GPIO 0 module. So let's call GPIO 0 dots button. And as you know, we are using second pin of the Raspberry Pi computers for button. For this reason, let's define as value 2. And also, let's move to a new line and let's create our LED variable. So let's create LED1 variable and let's call here our LED class. So for this, let's call first GPIO 0 module and let's call our LED class and open and close parentheses. And as you know, our LED pin number is 4. That's why we need to define here value 4. Alright. We are done. As you know, we will do this process 3 times. For this, we need to create a loop that can process 3 times. So let's create a new variable here and also the variable control our loop. For example, let the variable name be variable x and let's assign value 3 And also let's maintain new line and let's call here I while loop. And also if our x variable is greater than 0, let's do all of the operations in the while loop. And also let's move inside of our while loop, and now we need to check if the button is pressed. As you know, this is very simple. If you want to do this operation, let's call here our bottom variable, so which is bottom 1, and let's call wait for press method, and also open and close parentheses. And also if we enter the button, we will control the R LED, right? For this, we will learn a new method here. And also, with this method, we can control our LED for turning on and also for turning off. So what do I mean? That is, the method we will use turns it off if the LED is on, and also turn it on if it is off. So the name of this our new method is toggle. So for this, let's call here first our LED variable, which is LED1, and put a dot, and let's call here toggle. And also open and close parentheses, and let's move to a new line. And also, I told you that we will give some reaction time. So for this, we should use city function here. So let's call time.sleep. And let's wait for 1 second. And also let's move to a new line, and as you remember, we are controlling all of the steps for 3 times, right? For this reason, we should decrease our x variable by 1, because when we do something like this, we can control our loop for 3 times. So let's decrease our x variable now by 1. Alright, my dear friend, we are done. So now, if we run our code, and you see here, we didn't get any error. Alright, my dear friend, in this lesson, we developed our second example. So now, let's move on to our next lesson and learn the GPIO topics very well. This is a DC motor you see in my hands. DC motors are motors that can move forward and backwards. It can generally be used in remote control cars, mobile robots, and some aircraft. DC motor has 2 different lines, so here and also here. Let's focus now. Here and here. These lines allow the motor to go forward and backwards. For example, if the red line is positive, the black line is negative, the motor will move forward. And by the way, if the red line is used as negative, the black line is positive, the motor will move backwards. In order to control the DC motor with Raspberry Pi computer, we need a DC motor driver circuit. So here is our DC motor driver circuits, and also we will use the L298 circuit board as a driver circuit. So here is our L298 and motor driver circuits. As you can see, our circuit has a 12-volt input. So here, and also GND line here. For this circuit, we need to give an external 12-volt input. So here is our power supply. Let's focus now. And we will use 12 voltage. And also let's connect our external power supply to the L298 and driver circuit. Alright. The pink one is our 12 voltage, and also the blue one is our GND line. So now let's connect this. So here is our 12 voltage of our driver, And let's connect this. Alright, and here is our JND line of our power supply, and let's connect the blue one to our JND input of our driver. So, like this. Also, we need to connect one end of the JND line to the JND line on the Raspberry Pi board. So, here is the one more cable for connecting between our driver and also Raspberry Pi computer JND line. So now let's connect this. So let's connect. Alright. Why did we do something like this? Because this is a default connection in the driver's circuit we use. And as you can see here, we have lines from and 1. So here, 2 and 4. Since we can control 2 different motors instantly with our driver's circuit. So that's why we have 4 different control lines. We will use a DC motor and therefore we need to connect the N1 and N2 lines to the GPIO pins on the Raspberry Pi computer. We will use pins 14 and 15 for this. So now let's connect our GND line to the Raspberry Pi computer. So here is our Raspberry Pi computer and the third one is our GND line. So let's connect now. And here is our GPIO 14 pin, which is the first line, and this is our GPIO 15 pin, and which is the fifth line. So now let's connect these pins to do N1 and N2 orderly. Alright, the yellow cable that we will connect to the N1. So here is our N1 pin. And the green line that we will connect to the N2 input pin. Alright, my dear friend, we are done. Finally, we need to connect our DC motor to our driver circuit. For this, we will use the out1 and out2 lines you see here. So here is our out1 and out2. So now let's connect our DC motor to do out1 and out2. Alright, my dear friend, we are done. So now, let's move to the Raspberry Pi computer and let's control our DC motor using Python programming language and using Raspberry Pi computer. Alright, my dear friends, so now let's start writing our Python codes for controlling DC motor using Raspberry Pi computer. So now, let's connect our Raspberry Pi computer. And also, let's open our Visual Studio Code IDE for this. Let's open the terminal. And let's type code here and let's press enter. And you see here we have successfully opened our Visual Studio Code IDE. And now, if you want to control DC motor using Python, let's move to the project folder and let's create a new Python file here. For example, let the Python file name be motor_control.py. And also let's press enter. If you want to control any DC motor using Raspberry Pi computer, what you have to do now is to import our GPIO 0 module. So now let's import GPIO 0 module. For example, let's use as a short way, let's use our GPIO 0 module as, for example, GP. And also, let's move to a new line. In this new line, we will import our time module because we will give some reaction time for moving DC motor forward and also backwards. For this reason, let's import time module here. And also, let's move to a new line. In this new line, we will learn a new class. The name of this class is a motor class. With this class, we can successfully define our DC motor pins, and also we can successfully control our DC motors. For this, let's create a new variable here. Let the variable name be, for example, motor. And let's call our motor class. And also open and close parentheses. In the parentheses, we will enter two different parameters here. The first parameter will be our forward pin. We can use any pin we want here. I will use 14 pin of the Raspberry Pi for moving DC motor forwards. And also the second parameter. Alright, let's define as 14. And the second parameter will be our backward pin. As you know, our backward pin is 15, that's why I define as 15 here. And also, let's move to a new line. So now we will learn some methods for controlling DC motor. The name of these methods are forward and backward. And also, if we want to use forward and backward methods, first let's call here our motor variable. And let's put a dot and let's call here first forward. And also open and close parentheses and let's move to a new line. And then let's control our DC motor for 1 second. So let's call time.select function and let's define value 1 here. And let's control our DC motor for moving backward. For this, let's call here motor dots. Our new method name is backwards. And also open and close parentheses and let's give some reaction time to the backward command. So let's call here time.sleep and let's define as value 1 here. Alright, my dear friend, we are done. So now, if we run our codes. Alright, I will run my code now. And also, you are showing my DC motor now. And also, let's run our code. Alright, we got an error because we used the wrong method name here because our method name is backwards. So, sorry for this. Let's run our code again. And you see here, our DC motor moved forwards and backwards orderly. And also it did it for 1 second. Of course, we can also adjust the speed of our DC motor. For this, we should move inside of our forward and backward function, and also we can call it as method, and we will enter the value between the value 0 and also value 1. For example, if I set it as 0.5, our DC motor speed will be half speed. For example, let's check our code again, and also I will show you my webcam right now. And if we run our code like this, and you see here, when the motor moved forwards, it will go half speed, and also when the motor moved backward, it will go faster than forward. So here is the result. Alright, my dear friend, in this lesson we learned how to control DC motor using Raspberry Pi computer. So now let's move on to our next lesson and learn the basics of Raspberry Pi GPIO pins better. Yes, my dear friend, as you know, we learned how to use pins related to our Raspberry Pi computer in our previous section. Now we will learn and use pins at a more advanced level. With this section, we will learn digital input and output topics, and also we will learn analog input and PWM topics together with you. So let's get starting wasting any time and learn advanced pin usage. Yes, my dear friend, in this lesson we will learn the digital output process on our Raspberry Pi computer. In fact, the digital output allows us to power the material we want to control. For example, let's consider an LED. We use the digital output to control this LED. So we can turn on the LED's lights, and also we can turn off the LED's light. So let's learn about digital output on our Raspberry Pi computer now. First, let's go and create our circuit. We will use the same circuit as on Schroding LED lesson. So let's get started. So now let's plug in our LED to the breadboard. So the left side is our positive line and the right side is our negative line. So now let's connect our LED to the breadboard. And you see here, we are done. And also, let's plug in our jumper cable into the breadboard. And also the pin cable is representing our positive line. That's why I plug into the here. And also the blue one is representing negative line. So which is ground. Alright, so now let's connect these two cables to the Raspberry Pi computer. If you want to do this operation, first let's start with blue cable. The negative line is representing GND line, which is ground line. That's why we should use the ground line of the Raspberry Pi computer. And also this is the third one. So here is one, here is two, and here is third. So now let's plug into the Raspberry Pi computer. And also this is our positive line, and also if we want to use positive line of the Raspberry Pi computer, and also if we want to use any control device using Raspberry Pi computer, we should use the GPIO pin. I will use the 17 GPIO pin, that's why I plug into the 6th port of Raspberry Pi computer. So when we look at more closer, this is first, this is second, this is third, fourth, fifth, and sixth. Alright. And you see here, we have successfully connected our LED to the Raspberry Pi computer. So now let's move to the Raspberry Pi computer and let's write in Python codes for turning on LED. Alright, my dear friends, so now let's connect our Raspberry Pi computer. For this, here is our IP address, so now let's connect this. And here is our Raspberry Pi operating system, so now let's open our resistor code IDE. Open the terminal and let's type code here. And also let's press enter. Alright, here is our ID. So now let's create a new Python file here. Let's move to the project folder and let's collect this. And let the Python file name be, for example, GPIO. Intermediates. .py. And also let's press enter. Alright. So now, if we want to use digital outputs with Raspberry Pi computer, what we have to do now is to learn a new module. The name of this module is rpi.gpio module. With this module, we can successfully control our GPIO pins. For this, let's import our new module here, rpi.gpio, and let's use this module as, for example, GPIO. And also, let's move to a new line. If we are going to do a pin control with this module, we need to learn a function so that we can use all of the pins of the Raspberry Pi computer. The name of this function is setMod function. So now let's call our setMod function here. For this, let's call here first our GPIO module name. Alright, let's call GPIO and put a dot. And let's call here setMod function. And also open and close parentheses. In the parentheses, we will enter one parameter here. This parameter makes our pins usable. The name of this parameter is BCM. So let's call GPIO.BCM. And also, let's move to a new line. In this new line, we will set our pin for controlling LED. Because if we want to control any device using rpi.gpio module, we should set our pin for output and input operation. So let's learn a new function here. The name of this function is setup function. So now let's call here our setup function. So gpio.setup. And also open and close parentheses. In the parentheses, we will enter two different parameters here. The first parameter represents our pin number that we want to control, and the second parameter does the input and output operation. As you know, our pin number is 17, that's why I defined as 17 here. And also put a comma. At the second parameter will be our input and output operation. As you know, we want to control an LED, so we will give some voltage to the LED. That's why we need to set it as output operation. For this reason, we should learn a new parameter here. The name of this parameter is out. So let's call now GPIO dot out, and we are done. If we do something like this, we can successfully set up our 17 pin as an output pin. So let's continue. Let's move to a new line. In this new line, we will learn a new function here. With this function, we can successfully control our pin. So the name of this function is output. So now let's hold here GPIO dot. So let's collect the GPIO dot output. And also open and close parentheses. The first parameter will be our pin number that you want to control. So as you know, this is 17, and the other parameter indicates whether it's powered up. So if I set it as GPIO high, we can successfully turn on the LED. But if we set it as GPIO.flow, we can successfully turn off the LED. For example, let's think about our DC motor. If I set it as high, our DC motor can work, but otherwise, if I set it as low, our DC motor can't work. That's why we need to pay attention to here. So now let's turn on the LED. For this, let's set it as GPIO.high. Alright, my dear friends, we are done. So now I will show my LED to you. Alright, so now let's run our code. And you see here we have successfully turned it on the LED. For example, let's turn off the LED using rpi.gpio module. For this, we should call here gpio.low. And also, if we run our code now, and you see here, our LED is turned off. So here is the result. And for example, let's import our time module here. And let's turn on the LED for 1 second. And let's turn off the LED for 1 second. For this, let's change as high. And also let's move to a new line and let's call here our sleep function. And let's define as value 1. For example, let's change this time as 2 seconds. And let's call here our GPIO dots output function again. And as you know, the first parameter will be our pin number that you want to control. So this is 17. And the second parameter will be our power parameter. So we will set it as GPIO dot low. And also let's move to a new line and let's hold here time.sleep function. And let's set it as 2 seconds. Alright, my dear friend, so now if you run our code like this, and you see here, it's turned on for 2 seconds, and it's turned off for 2 seconds. Alright, my dear friend, in this lesson we learned how to control LED using digital outputs. So now let's move on to our next lesson and learn how to control digital inputs using Raspberry Pi computer. Yes, my dear friend, in this lesson we will learn about digital input to with a video. We can perform button control with digital inputs. There is something we should pay attention to here. When we read data with a digital input, it directly sees it as true. That is, true is returned without pressing the button. For this reason, we do all main work with the else condition instead of the if condition. So now let's build our circuit. For this, we need a breadboard here, and also we need a button. And also, we need 2 cables for connection between Raspberry Pi computer and our button. So now, let's connect our buttons to the breadboard. So like this. And as you know, if we want to use the button, we should use these 2 lines. So now let's connect our blue cable to the button line. And also let's use our blue cable as JND line. So now let's connect our Raspberry Pi computer's ground line. So as you know, the third one is our ground line. So here, and also let's use our pin cable as the GPIO pin of the Raspberry Pi computer. For this, for example, let's use a different line. I will use the 23 pin number. So for this, the 8th one is our 23 pin. So now that's why I will connect my pin cable to the 23 pin number. So here. Alright, my dear friends, we are done. So now, let's move to the Raspberry Pi computer and let's write our digital input codes. Alright, my dear friends, so now let's create our Python codes for digital inputs. For this, let's connect our Raspberry Pi computer. So let's open VNC Viewer. And you see here is our IP address, so now let's connect this. And let's open the terminal, and let's type code here, and let's press enter. Alright, my dear friend, so now let's move to our project folder, and let's create a new Python file. Here, let the Python file name be this time, for example, GPIO _ intermediates. underscore 2 dot pi. And also let's press enter. If you want to use any button using Raspberry Pi computer, what we have to do now is to import rpi.gpio module. So now let's import rpi.gpio module and let's use as GPIO. And also let's mutate new line and let's give some reaction time for digital inputs. For this, let's import our time module. Alright, my dear friends, we are done. So now let's mutate new line. Now let's come and prepare our pins so that we can use them. As you know, if we want to do this operation, we should call setMode function. So now let's call here gpio.setMode. And also open and close parentheses. In the parentheses, we will answer one parameter here, which name is, as you know, BCM. For this reason, let's import gpio.bcm and also let's mutate new line. So now we will set up our pin which we want to use. As you know, we will use 23 pin number of the Raspberry Pi computer. That's why we should set up our 23 pin. For this, as you know, we should use setup function. So let's call here gpio dot setup and also open and close parentheses. In the parentheses, as you know, our first parameter will be our pin number that we want to use. As you know, this is 23. The second parameter is the parameter required for us to be able to read digitally. So if you want to do a digital read operation, we should call here gpio dot in parameter. And we are done. So now let's mutate new line. Alright, so now let's read the data from the 23rd pin number of Raspberry Pi computer. For this operation, we should learn a new function. Here, the name of this function is input. And also in the input function, we will enter our pin number. For example, I am not pressing the button right now. Let's check which value we will get. For this, let's call print function here. And let's call here our new function. Our new function name is input. And also open and close parentheses. In the parentheses, we will enter our pin number, and this is 23. If you run our code like this, alright, we got an error because we write the wrong model name. So we wrote like the gpeep. So let's change as gpio. And let's run our code again. And you see here, we got the output as 1. But if I press the button, and if we run our code again, and you see here, we got the output as 0, we can think about the value 1 is representing value true. And also we can think about the value 0 is the reverse of the value 1. For example, let's do some loop operation with the button. For this, let's mutate new line and let's call here while true if our gpio dot input function reading any data from the 23rd pin number, let's print hello. Otherwise, let's move inside of our while loop again and let's call as condition and let's print this time pressed the button. Alright, and also let's give some reaction time to this condition. For example, let's give as 1 second, let's call select function and let's define value 1. And let's move to the else condition and let's call here our static function again. And let's define value 1 again. Alright, if we run our code like this, and you see here we got the output as hello. Because I told you that true is returned without pressing the button. But if I press the button, and you see here, we got the output as press the button. That's why we need to pay attention to this. And you see here, we got the output as hello, but if I press the button again, and you see here, we got the output as press the button. So here is the result. Alright, my dear friends, in this lesson we learned how to use digital input using Raspberry Pi computer. So now let's move on to our next lesson and let's create some examples using Raspberry Pi computer. Yes, my dear friends, we will learn about PWM in this lesson. PWM stands for Pulse Width Modulation. Thanks to the pins on the Raspberry Pi computer, we can adjust the voltage on the device we want to control. For example, we want to turn on an LED. We can turn it on at half strength. Or we can control an LED according to the darkness of the night and say, or we can control the speed of the engine in all vehicles. For example, we can detect objects according to speed limits and adjust the engine speed with PWM. Now, let's make a PWM example with our Raspberry Pi computer. Of course, we cannot use all pins as PWM. There are some special pins for this. So here is our 18 pin on the Raspberry Pi, and also here is our 12 pin on the Raspberry Pi, which is useful for PWM operation, and also the 13 pin is useful for PWM operation on the Raspberry Pi computer. So now let's build our circuits. Here is our cables, here is our LED, and also here is our breadboard. So now let's connect this. I will use 18 pin on the Raspberry Pi computer for PWM operation. And also the left leg of the LED is a positive line. So I will connect LED positive line to the 18 pin on the Raspberry Pi computer. So now let's focus now. The sixth one on the pins is our 18 pin of the Raspberry Pi computer. So here is the 1, here is the 2, here is the 3rd, 4th, 5th and 6th. So now let's connect. And also the right light of the LED that we will connect to the ground line on the Raspberry Pi computer. So now let's connect this. And we are done. So now let's move to the Raspberry Pi computer and let's do PWM operation using Raspberry Pi computer. Alright, my dear friend, so now let's connect our Raspberry Pi computer. For this, let's open VNC Viewer. And here is our IP address, so now let's connect this. And also, let's open the terminal. And let's type quote fear and let's press enter. Alright, we have successfully opened our Visual Studio Code IDE. So now let's move to our project folder. And let's create a new Python file here. Let the Python file name be, for example, GPIO underscore intermediates underscore 3.py. And also let's press enter. Alright. If you want to do a PWM operation using Raspberry Pi computer, what we have to do now is to import our rpi.gpio module, because with this module we can successfully do PWM operation. So now let's import RPI dot GPIO module. And also let's use this module as, for example, GP this time. And also let's move to a new line. As you know, we want to use all of the pins on the Raspberry Pi computer, right? For this, we should prepare our pins for controlling pins. As you know, if you want to do this operation, we should call here setMode function. So for this, let's call here gp.setMode. And also open and close parentheses. In the parentheses, we will enter our parameter for controlling pins on the Raspberry Pi computer. And as you know, which is gp.ecm parameter. And we are done. So now let's move to a new line. Now we need to set our pin as input or output. As you know, we want to control a device. For this reason, we will set our pin as output. So now let's call here our gp.setup function and also open and close parentheses. As you know, the first parameter would be our pin number and our pin number is 18. So let's define as 18 here and also put a comma. And as you know, we want to control LED. That's why we need to define our pin as an output. For this, let's call here gp.out, and we are done. So now let's move to a new line. Now, we need to set our 18 pin as PWM so that we can perform PWM operation. For this reason, we should learn a new class here, and our new class name is PWM. If you want to use PWM class using Python programming language, what we have to do now is to create a new variable here. For example, let the variable name be PWM and put an equal sign, and let's call here our new class, which is PWM. And also open and close parentheses. In the parentheses, we will enter two different parameters here. The first parameter will be our pin number. As you know, our pin number is 18. And the second parameter will be our frequency. So what is this? In fact, it is the number of vibrations per unit time. The higher the frequency, the more vibration there will be at the control of the devices we will control is provided more smoothly. For example, if I set it as 1000 here, so let's define as 1000 here, we will get better results than, for example, value 10 or for example 120. That's why I define as 1000 here, and also let's move to a new line. And also, if we want to do a PWM operation, what we have to do now is to call here start method for PWM operation because we need to start our duty cycle, and also for this we should call our start methods for PWM object. So now let's call PWM.start and also open and close parentheses. In the parentheses we will enter our duty cycle parameter and also we will enter value 0 here. So why? In fact, duty cycle is the rate of opening and closing. Here I set it to 0, because here we will start from 0 to 100 on off rates. In this way, we will adjust our LED intensity from 0 to 100. The value 0 here is 0 volts. The value 100 is 5 volts. So now let's continue and also let's move to a new line. And in this new line, we will change our duty cycle for opening and closing rates. We can do this operation with a for loop, but let's come with our 20s and import our time module. In this way, we can give some reaction time and we can better observe the result. So let's move to the top and let's import our time module. And also let's move to the bottom again. So now, let's create our for loop here for duty. And as you know, this is our element variable name. And here we will make a loop that returns numbers from 0 to 100. For this, we should use range function in Python programming language. So now let's call here our range function. open and close parentheses. In the parentheses, we will enter two different parameters here. The first parameter will be our starting value, and as you know, our starting value is 0, and the second parameter will be our ending value. If I set it as, for example, 100 here, our last parameter will be returning value 99, because the 100 is not included in the range function. So how can we solve this? If we want to solve this operation, we should define as 101. So now, like this. And also put a colon and let's move inside of our folder. Now, what we need to do is to adjust the light intensity. There is a function that we can use for this. The name of this method is change duty cycle method. With this method, we can successfully change the duty cycle. For this, first let's call here our PWM variable, and also let's call our PWM and also put a dot, and let's call here our new method, which is change duty cycle. And also open and close parentheses. In the parentheses, we will enter one parameter here. As you know, if you want to observe this, we need to use the element variable in the for loop, because in this way we can observe the light intensity obtained. For this reason, that's why I will enter duty here. And also let's give some reaction time for our PWM operation. Let's maintain new line, and let's call here our still function. And let's give reaction time as 0.1 seconds. Alright, my dear friend, we are done. So now, before run our codes, I will show my webcam to you. So, I will open my webcam right now. And also, if I run my codes, and you see here, our LED intensity is increasing. So here is the result. And you see here our code is terminated. So here is our PWM result. Alright, my dear friend, in this lesson we learned how to control PWM using Raspberry Pi computer. So now let's move on to our next lesson and let's learn more about Raspberry Pi computer. Yes, my dear friend, in this lesson we will install OpenCV on the Raspberry Pi computer so that we can make image processing applications. So what is image processing? In fact, we can say that everything a person sees can be done with programming. For example, when we see a car, we understand that it's a car. However, when we view the car with the camera does not recognize that it's a car. We also use image processing to process images and detect objects. So now let's go to the installation and install the OpenCV module on the Raspberry Pi computer. For this, let's open VNC Viewer here. And here is our IP address. So now let's connect this. And also, if you want to install OpenCV module on the Raspberry Pi computer, first let's open the terminal. And here is our installation codes. We will type all of the codes in the terminal. First, let's start with sudo apt-get update command. So now let's copy this. And also let's paste it here. And let's press enter. This process is updating our Raspberry Pi computer. So now let's open our other commands. And let's copy the second one. Right, let's copy now. And let's paste it here. And also let's press enter. And by the way, it may take a long time. So let's continue when it's over. Alright, my dear friend, our second process is done, so now let's do the third one, which is for installing OpenStevie module to the Raspberry Pi computer. Let's copy this. And also let's paste it here. And let's press enter. Look, we encountered an error, as you can see here. Sometimes we can get errors like this, because it can give different results on each Raspberry Pi computers. But also we have a different command for this. So now let's type the command, which is pip install OpenCV-contrib-python. And we are done. So now let's press enter. And you see here, we are downloading OpenCV module to the Raspberry Pi computer. So let's continue when it's over. Down slow. Down. dear, 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 oh, don't run, don't run, hey, don't run, say for food, like this, that goes in for it, oh, that don't run, oh, that don't, what, it don't, that don't, oh, that don't run, it don't run. Do a dear, dear, for the phone, for the fire, for the ever, for the open, it, oh, I open, for the, it open, oh, I open, do a dear, dear, they open, bounce, bounce out, bounce, boom, bounce, go, bounce, bounce, go. Alright, my dear friend, we are done. We have successfully installed OpenCV module to the Raspberry Pi computer. Now let's check the installation. Of course, this process takes a long time. For this reason, it's worth waiting. If you want to check the installation of OpenCV module, let's type here Python. So what is this? Basically, it will be opening an Python file on the terminal. And also, if you want to use OpenCV module on the Raspberry Pi computer, what we have to do now is to import a new module. The name of this module is CV2. CV2 module is representing OpenCV module. For this, let's import CV2 module and also let's press enter. And you see here, we didn't get any error. And also, let's check the OpenCV version. For this, let's call here CV2 dot underscore underscore version underscore underscore, and let's press enter. And you see here, our OpenCV version is 4.5.5. So here is the result. We have successfully installed OpenCV module to the Raspberry Pi computer. Alright, so now let's move on to our next lesson and learn the basics of OpenCV better. Yes, my dear friend, in this lesson we will learn how to read an image and display it on the screen. An image is called a matrix in digital environment. The matrix consists of two structures called rows and columns. Each row and column has certain values, and these values allow us to see images. Of course, each value represents a concept we call pixels. Pixels are the smallest unit of an image. So what do I mean? Let's think about. This is our image. And for example, let's select any points on this image. For example, let's select this. You see here, and also let's change the color. For example, let the color be green. And let's select any point of the image. And this is our pixels. Because the pixels are the smallest unit of an image. So what exactly are column and rows? When we think this is our image, this side is representing our rows. And also this side is representing our columns. For example, let's think about any book. These are rows, right? From left to right, and also from top to bottom is representing our column. Like this. Alright, so now let's learn how to read an image and display it on the Raspberry Pi computer. For this, let's connect our Raspberry Pi computer. Open the VNC viewer right now. And let's connect this. And also open the terminal and let's type here code. And also before write our codes, let's open the Google. And let's go to the pixels.com. Alright, not pixel, pixels. Correct. So let's download any image on this web page because all of these are free. For example, let's download dog image. So I will write here dog. And let's search. For example, let's select this. And also let's download now. Let's select the custom and let the width value be, for example, 500 by 500. Alright. And you see here we have successfully downloaded. So now, if we want to do any operation on the image, what we have to do now is to keep our image. And we should paste our images to our project folder. As you know, our project folder is Raspberry Pi projects. So now let's keep this. And let's paste it into our project folder. And you see here we are done, so now let's rename this. For example, let the image name be, for example, IMG, and let's press enter. Alright, my dear friend, we are done. So now let's read this image and let's display it on the Raspberry Pi computer display. For this, let's move to our project folder and let's create a new Python file. Here, let the Python file name be image processing _1.py. If you want to do any image processing operation, what you have to do now is to import our OpenCV module. For this, let's import our CV2 module. And also, let's move to a new line. Alright, in this new line, we will create a new variable here, and also the variable that we will create is representing our matrix. For example, let the matrix variable name be img and also put an equal sign. And now we will read our image. For this, we should learn a new function. Here, the name of this function is imread function. So now let's call this CV2.imread and also open and close parentheses. In the parentheses, we will enter one parameter here. The one parameter is representing our file name and its extensions. And also, if we want to define our parameter, let's create double quotes. And also, let's define our file name, which is img, and also its extensions, .gpg. Alright, we are done. If we run our code like this, and you see here, we didn't get any error. So now let's display our image. For this, we should turn a new function here. The name of this function is IamShow function. We will enter two different parameters in the IamShow function. First, let's call our IamShow function here. And also open and close parentheses. The first parameter will be our window name. And also, if you want to set window name of IamShow function, let's create double quotes. And for example, let the window name be tests. And also the second parameter will be matrix variable name. And as you know, our matrix variable name is img. So why did we define img matrix variable here? Because we want to display on the screen. That's why I defined here. And also, if we run our code like this, and you see here, we didn't get any output. So why? Because our codes run very quickly. That's why it worked and it's over. If you want to keep it on the screen, we need to learn a new function. The name of this function is waitK function. And also, let's learn our new function usage. For this, let's move to a new line and let's call here co2.waitKey. And also open and close parentheses. And by the way, if you want to keep our image on the screen continuously, what we have to do now is to define value 0 here because this is a default value. And if we run our code like this, and you see here, we got the output as you want. And of course, we can show it in time. For example, let's display this image for 10 seconds. For this, let's move to the waitK function again. And for example, if I set here 1000, we will display our image for 1 second. For example, let's check our code now. And you see here, it came and gone quickly because we defined as for 1 second. But if I set it as 10,000, and if we run our code again, and you see here, our image will be displaying on the screen for 10 seconds. And it's gone. So we are done. Alright, my dear friend, in this lesson we learned how to read an image and display it on the Raspberry Pi computer. So now let's move on to our next lessons and let's learn the basics of image processing better. Yes, my dear friend, in this lesson we will learn about color formats. In general, the color formats allow us to perform different operations on images. For example, everything we view with our eyes today is in RGB color format. However, the module we are using displays it as BGR. Because BGR is set as a default format, today when we do object detection, we need to convert our image to gray color format. Because detecting on gray color gives easier and more accurate results than color images. So let's learn how we can change our color format. For this, let's connect our Raspberry Pi computer. So let's search VNC Viewer. And also here is our IP address, so now let's connect this. And also open the terminal and let's type here codes. And we have successfully opened our Visual Studio Code IDE, and also let's move to our project folder. And let's create a new Python file here. Let the Python file name be, for example, image processing _2.py. And also let's press enter. If you want to do color format operation on Raspberry Pi computer, what you have to do now is to import our OpenCV module. For this, let's import our CV2 module. And also, let's move to a new line, and in this team line, we will read our image. For example, let the matrix variable name be do and put an equal sign, and let's call IamRead function here, and also open and close parentheses. In the parentheses, we will define our image file name and also its extension. So let's create double quotes and let's define img.jpg file. And we are done. If we want to convert any color format using OpenCV module, what we have to do now is to create a new matrix variable here, because with this matrix variable, we will assign the color change image. For example, let the matrix variable name be gray_image, and also put an equal sign, and now we should learn a new function here. With this function, we can successfully convert color format of an image. The name of this function is CVT color function. So now let's call here our CVT color function. So let's try to CVT color and also open and close parentheses. In the parentheses, we will enter two different parameters here. The first parameter will be our input matrix that we want to convert color format. So as you know, which is dog. And also put a comma. At the second parameter will be our spatial codes. With these spatial codes, we can successfully convert color format of our image. For this, let's call here cv2.color. And you see here there are a lot of color formats that we can use, but also we want to convert color format of our image as gray format. For this, let's call here color_bgr to gray. And we are done. For example, if you run our code like this, and you see here we didn't get any error. So now let's display our original image and also our gray format image. So for this, let's move to a new line and let's call here IamShow function, because we want to display our images on the Raspberry Pi computer. So let's call here IamShow, open and close parentheses, let the window name be, for example, original. And let's display our source matrix, which is doc. And also, let's move to a new line. In this team line, let's call here our IamShow function again. And also, open and close parentheses, let the window name be this time, for example, gray image. And let the second parameter be our gray image matrix. Alright, so now let's call our read key function, because we want to keep our images on the screen. Read key. And also let's define value 0. Alright, my dear friend, we are done. So now, if you run our code like this, and you see here is our original image. As you know, our window name be original, and here is our gray image. Our image window name is gray image. So here is the result. For example, let's convert our original image as a RGB color format. For this, let's terminate our code. If you want to do this operation, let's press any key on the keyboard. Let's move to the bottom of doc matrix variable, and let's create a new variable. Here, let the matrix variable name be RGB image, and also let's call here CVT color function again. And also open and close parentheses, our source matrix variable name be, as you know, doc. And the second parameter will be our spatial parameter. So let's call here cv2.color underscore. And also, if we want to convert our image as RGB color format, let's type here BGR to RGB. And we are done. And finally, let's call our IamShow function again, and let's display this time our RGB image. let the window variable name be RGB image. And let's display our RGB image matrix variable. Alright, my dear friends, so now let's run our code again. And you see here is the result. So here is our RGB image, here is the our BGR image, and here is the our gray image. Alright, my dear friends, in this lesson we learned how to convert color format of an image. So now let's move on to our next lesson and learn the basics of image processing better. Yes, my dear friend, in this lesson we will learn how to resize an image. So let's get started. For this, let's connect our Raspberry Pi computer. So here is our VNC viewer. And also let's connect IP address of Raspberry Pi, and let's open our terminal and let's type here code and let's press enter. Go right. Basically, if we want to resize an image using OpenCV module, we should learn a new function here. The name of this function is resize function. With this function, we can successfully resize any image that we want. So let's do resizing operation now. For this, let's move to our project folder and let's create a new Python file. Here, let the Python file name be image processing underscore 3.py, and also let's press enter. As you know, we will do OpenCV operation, right? For this, let's import our CV2 module. So let's import CV2 and also let's move to a new line. In this new line, we will read our image for resizing operation. For example, let the matrix variable name be original. And also let's call img function here. And let's define our img.gpg file. And we are done. So now let's move to a new line. In this new line, we should create a new matrix variable. Here, with this matrix variable, we will resize our original image. For this, for example, let the matrix variable name be resized underscore image. And also, let's learn our new function. Our new function name is resize function. For this, let's call here CV2.resize. And also, open and close parentheses. In the parentheses, we will answer two different parameters. Here, the first parameter will be our source matrix that we want to resize. As you know, this is original. And the second parameter will be our tuple. With this tuple, we will define our new width and height of an image. For example, if I set it as 320 by 480, the width value will be 320, the height value will be 480. And if you run our code like this, and you see here, we didn't get any error. So now let's display our original image and also our resized image. For this, let's move to a new line and let's call here imshow function. And let the window name be, for example, original, and let's display our original matrix. And also let's move to a new line and let's call here imshow function again. And let the window name be this time, for example, resized image. And let's display this time resized image matrix. Alright. And also, finally, if we want to keep all of these images on the screen of Raspberry Pi computer. What we have to do now is to call waitKey function. For this, let's call here cv2.waitKey, and also let's define what is 0 here, and we are done. Alright, my dear friend, so now let's run our code. And you see here is our original image. And here is our resized image. So here is the result. For example, let's increase the first parameter of our tuple. So what do I mean? Let's move to our resize function again and let's change the first value of the tuple as, for example, 640. And if we run our code like this, and you see here, it's wider than the original image. So here is the result. Alright, my dear friend, in this lesson we learned how to resize an image. So now let's move on to our other lessons and learn the basics of OpenCV better. Yes, my dear friend, in this lesson we will make our first image processing example. With this example, we will resize an image and convert it to gray format. As you know, we learned these processes in order in our previous lessons. So let's do this example now. For this, let's open VNC Viewer. And let's click this. And also here is our IP address, so now let's connect this. And here is our operating system. For example, let's use this time different image. For this, let's open the Google. Let's reach pexas.com. For example, let's search an cat image. So let's type here cat and let's search. Alright, for example, let's use this image. So let's click the custom and let the size be, for example, 320 by 480. And also let's download now. And we are done. So now let's open the terminal and let's type here code. And also, let's keep our new image and let's drop it to our project folder. And you see here, we have successfully downloaded our new image, and also let's rename it now. For this, let's click Rights and let's select Rename. And for example, let the image name be cat. And let's press Enter. Alright, so now let's move to our project folder and let's create a new Python file. Here, let the Python file name be, for example, image processing example _1.py. And let's press Enter. Basically, if you want to do resizing and also converting color operation, what you have to do now is to import OpenCV module. So now let's import CV2 module here, and also let's move to a new line. So now let's read our new image. For this, let's create a new matrix variable. Here, let the matrix variable name be, for example, cat. And also put an equal sign and let's call IamRead function here. So let's write here IamRead. And also let's create double quotes and let's define our file name. As you know, our file name is cat and its extensions is GPG. And we are done. And also let's move to a new line. In this new line, let's resize our new image. For example, let the width value be 500 and let the height value be 500. For this, let's create a new variable. Here, let the matrix variable name be resized underscore image. And as you know, if you want to do resize operation, what you have to do now is to use resize function. For this reason, let's call here cv2.resize. And also open and close parentheses. As you know, we will enter two different parameters here. The first parameter will be our input matrix that we want to resize, and which is cat. So let's define as cat, and also put a comma. And the second parameter will be our width and height value, and also it must be in the tuple. That's why we need to create tuple here. And let's define the width value as 500, and let's define the height value as 500. And we are done. So now let's move to a new line. Basically, we have successfully resized our image, right? So now let's convert our resized image to gray image. For this, we should create a new matrix variable. Here, let the matrix variable name be, for example, gray. So let's try it here, gray underscore cat. And as you know, if you want to do this operation, what we have to do now is to call cv2color function. So now let's call here cv2color function. And also open and close parentheses. The first parameter will be our input matrix. As you know, this is resized image, right? Not cat. So why? Because I told you that we will resize an image and convert it to gray format. That's why we will use resized image matrix variable here. So let's define our resized image. And also let's put a comma. The second parameter will be our gray format parameter. And as you know, this is cv2.color underscore bgr to gray. And we are done. So now let's check our code. If we run our code like this, and you see here, we didn't get any error. So now let's display our final image and also our first image. For this, let's move to a new line and let's call IamShow function. And let the window name be original cat. And let's display our matrix variable as cat. And also, let's move to a new line and let's call our IamShow function again. And let the window name be this time, for example, final image. For example, let's say final cat. And let's define this time gray cat matrix variable. So let's write here gray underscore cat. And we are done. And also, if you want to keep all of these images on the screen continuously, we should call our rate key function. For this, let's call here rate key. And let's define value 0 here. Alright, my dear friends, we are done. So now, if we run our code like this, and you see here is the original image. So here, and also here is our final result. Yes, my dear friend, in this lesson we have made first example about image processing. So now let's move on to our other lessons and learn the basics of OpenCV better. Oh, wait. Yes, my dear friend, in this lesson we will learn how to save an image using OpenCV module. For this, we need to learn a new function. The name of this function is IamWrite function. So let's get started. Here is our IP address, so now let's connect this. And also let's open our IDE, which is Visual Studio Code. Let's open the terminal and let's type here code and let's press enter. Alright, for example, we have a cat image, right? So here. So I'm waiting for opening the image. Alright, here is our image. For now, let's save this image as a different image. So what do I mean? For example, let's change the size of this image and let's save as, for example, cat2.jpg file. For this, let's move to our project folder and let's create a new Python file. Here, let the Python file name be image processing _4.py. And also, we will do a pulsive operation. That's why we need to import CV2 module here. And also, let's move to a new line, and in this new line, let's read our cat.jpg image. For this, let's create a new matrix variable. Let the matrix variable name be cat. And let's call IamRead function, which is for reading an image. So let's read. And also let's create double quotes and let's define our cat.jpg image. And for example, let's change the size of this matrix variable. For this, let's create a new variable here. Let the variable name be, for example, new image. And as you know, if you want to change the size of any images, what we have to do now is to call resize function. For this, let's call here cv2.resize, and also open close parentheses. As you know, the first parameter will be our input matrix, which is cat. And the second parameter will be our tuple. For example, let the size be 500 by 500. And also, let's move to a new line. So now we will save our new image variable as a new image. For this, we should use a new function. The name of this function is IamWrite function. If you want to use this function, let's call here cv2.IamWrite. And also open and close parentheses, and we will enter two different parameters here. The first parameter will be our new file name. And if you want to study it, what we to do now is to create double quotes here. And also we will enter a new file name and also its extensions. For example, let the new image file name be cat, for example, new underscore cat.jpg. And also, let's put a comma, and the second parameter will be the matrix you want to save. And as you know, this is new image. So that's why we should call here new image matrix variable. And we are done. So now, if we run our code like this, and you see here, we didn't get any error, and also, we have successfully created our new file, which is newcat.jpg. For example, let's open this. And here is our new image, and also here is our original image. So we are done. Alright, my dear friends, in this lesson we learned how to save an image. So now let's move on to our other lessons and learn the basics of image processing better. Yes, my dear friend, in this lesson we will learn how to open and play videos. Videos are formed by displaying sequential images one after the other. Images on webcams today are actual video. Of course, we will also perform imaging with the Raspberry Pi camera. However, now let's come and learn to open and play any video. So, let's get started. For this, let's open VNC Viewer. And here is our IP address, so now let's connect this. And also, let's open the Visual Studio Code IDE now. Open the terminal. And let's type here port, and let's press enter. Alright, my dear friend, before write our codes, let's open the Google and let's select a video from pexels.com. So let's open pexels.com and let's press enter. For example, let's select dog video. So I will write here dog and let's search. Let's collect the videos. For example, let's choose this video and let's select the size of this video. For example, let the size be 360 by 640. And let's click the download button. Alright, we are done. So now let's keep this video and let's drop it into the R project folder. And we are done. So now let's rename it. So let's click right and let's select the rename button. And for example, let the video name be dov_video.mp4. And we are done. So now let's create a new Python file here. Let's move to our project folder and let's create a new file. And let the Python file name be this time image processing_5.py and let's press enter. Alright, as you know, if you want to open any video using OpenCV module, what we have to do now is to import CV2 module. So let's import CV2 and also let's move to a new line. In this new line, we will learn a new class. With this class, we will open our video that we want to display. For this, we should create a new variable here. Let the variable name be, for example, dog_video. And also put an equal sign and our new class name is video capture class. For this, let's call here cv2.videoCapture and also open or close parentheses. In the parentheses, we will enter one parameter as a string data type. Because we will open a video, that's why we will define a string data type. For this, let's create double quotes. And in the double quotes, we will enter our video file name and its extensions, which is dog_video.mp4. And we are done. And now we have to create a while loop. Because videos are made up of sequential images. For this reason, we need to create a while loop to show the sequential images. For this, let's move to a new line. And in this new line, let's create while true loop. Then also, let's move inside of our while loop. So now we should create two different variables here. The first variable will be our control variable. If the video are reading, our control variable is returning us value true, but otherwise it's returning us value false. For this reason, let's create our new variable as control and put a comma. At the second variable will be our matrix variable. With this matrix variable, we will display our videos. For this, let the matrix variable name be, for example, frame, and put an equal sign. And if you want to display any videos using matrix variable, what we have to do now is to read our video capture object, so which is dog video. For this reason, let's call here our dog video object, and let's put a dot and let's call read method and also open and close parentheses. And also let's move to a new line. And we are done. So now we should call IamShow function, and with this IamShow function we will display our frame matrix. For this, let's call here steward2.IamShow And also open and close parentheses. Let the window name be, for example, video. And the second parameter will be our matrix variable name, as you know, which is frame. And also, let's move to a new line. Alright, now there is something we have to do. This is the terminate the loop with the conditional structure. In general, we have to do this when we want to play a video or get an image on the webcam, because this is the default. For this reason, let's create a new condition here. And with this condition, we will check any press on the keyboard. For example, if I press the ESC key, we will terminate our codes, like break our codes. For this, we will call here waitKey function. If I press the ESC key for 10 milliseconds, so let's call here tv2.waitKey. And let's define value 10 here. If the waitKey is equal to 27, so 27 is our ASCII value, so this is equal to ESC key on the keyboard. Let's move inside of our if condition and let's break our code. And we are done. So now, if we run our code like this, and you see here, we have successfully opened our video that we want to display. So here is the result. And also, if I pressed ESC key, alright, our code is finished. So let's run our code again. If I press the ESC key, and you see here, our code is terminated. So here is the result. Alright, my dear friends, in this lesson we learned how to open a video and play it. So now let's move on to our other lessons and learn the basics of OpenCV better. Yes, my dear friends, in this lesson we will continue on video operations. As you know, we learned how to open and play videos in our previous lesson. Now let's learn about our handy method. In some cases, the file name and extensions may be incorrect. For this reason, it's important that we create the condition so that we can control it, because we can easily find out whether there is a mistake or not. So let's get started. For this, let's connect our Raspberry Pi computer now. Open the VNC viewer, and also here is our IP address, so now let's connect this. And also open the terminal, and let's type here codes. And here is our code, which is for opening any videos. Let's do this operation on this code. For this, we need to move to the top of white ruler. And you see here is our video capture class, and we assign this class to the doc video object. So now let's do operation on doc video object. For this, let's create if condition here. And also if our doc video object is opened. So let's check doc underscore video dot is opened. Open and close parentheses. And let's move inside of our if condition and let's print, for example, file is correct. And also, if we run our code like this, and you see here, we got the output as file is correct. The otherwise, let's break our code. Now let's press the ASC key, and also let's move to the top again, and let's move to a new line. Let's call here as condition. So let's move to the main below and let's call as condition and let's print this time. For example, check the file name of the video. And for example, let's define our dog video name as incorrect. For example, let's do this as dog videos. And if you run our code like this, and you see here, we got the output as check the file name of the video. And you see here, it's very useful to use this method, which is opened. So let's continue. Sometimes the videos we play may not close completely. That's why we need to be sure of this. We have another method for this. The name of this method is release method. This allows us to close directly after the playing video is finished. So now let's learn how to use this method. For this, let's move to the bottom of all of the codes. And also we need to call our object variable, which is about video capture. As you know, this is dog video. So now let's call here dog_video and also put a dot. And let's call release methods. And also open and close parentheses. And also let's change the file name of this video as correct, as you know, which is dogvideo.mp4. And also let's run our code again. And you see here we got the output as file is correct and we are playing our videos. And you see here it's closed directly again. And of course we have one more function, which is destroy all the windows. This function allows us to close open windows. So let's learn how to use this. For this, let's move to a new line and let's call here our OpenCV module as CV2 and put a dot and let's call destroy all windows function and also open our close parentheses. And also, if we run our code like this, and you see here, we didn't get any error. So we are done. Alright, my dear friend, in this lesson we learned more about video operations using OpenCV module. So now let's move on to our other lessons and learn the basics of image processing better. Yes, my dear friend, in this lesson we will learn how to use the Raspberry Pi camera. Undoubtedly, people who own this computer use Raspberry Pi camera in their image processing projects. For this reason, we will make various applications by using this camera in image processing lessons. The Raspberry Pi camera you see in my hand. So now open the box. And you see, here is our Raspberry Pi camera. And also, the way this camera is connected is CSI. We will also make our connection to the camera port you see here. So here is our camera port. Let's focus now. And you see here, and as you can see, there is a blue area on the cable. So here is our blue area. When making our connection, the blue part will face towards to the computer's USB port. So now let's make our connection now for this. Let's open the click. So like this. And also, let's focus now. The blue part that we will connect will face towards the computer's VSP port, so like this. And also, let's close the connects. So we are done. And you see here, we have successfully connected our Raspberry Pi camera to the Raspberry Pi computer camera port. Alright, my dear friends, we are done. So now let's move on to our Raspberry Pi operating system, and also let's do example about Raspberry Pi camera. Alright, now let's come and perform the necessary procedures so that we can use our Raspberry Pi camera. For this process, we need to activate the CSI port on our Raspberry Pi camera. So let's do it. For this, let's open our VST Viewer. And here is our IP address, so now let's connect this. And also, let's open the terminal. And if we want to do this operation, let's type here sudo raspi-config. And also, let's press enter. And you see, here is our Raspberry Pi software configuration tool. And also, if you want to enable off to CSI port, what we have to do now is to reach interface option. And you see, here is our legacy camera support. So now let's move to this. And let's press enter. And let's select the enable, and also which is yes. All right, we are done. So now, let's press the ESC key, and let's reboot our computer. For this, let's type here sudo reboot, and let's press enter. All right, now we will wait for 60 seconds. Because we are restarting our Raspberry Pi computer. So now let's close our VST Viewer. And also let's open again. And let's connect again. Alright, my dear friends, so now let's come and read our Raspberry Pi camera. For this, let's open the terminal again. And let's type here, raspi still dash V. V means that short of the version. And also, if we press the enter, and you see here we have successfully read our Raspberry Pi camera. So we are done. For example, let's take a picture from the Raspberry Pi camera. For this, we have one more command. For this, let's type here, raspi still again. And also put a space and put a dash, and let's type here O. O means that the option to add an output file name. And also, if you want to do this operation, let's create a new folder here. Let the folder name be, for example, cam. And let's click OK. And also let's open our folder. And let's copy all of the paths for cam folder. So now let's copy. And also let's paste it here. And then we should continue here because we will give a name to our picture. For example, let the file name be image.jpg. And also, if you press enter like this, and you see here we take a picture. So now let's open this. And here is the result. So we are done. Alright, my dear friend, in this lesson we learned how to use a Raspberry Pi camera using terminal. So now let's move on to our other lessons and learn usage of camera with Python programming language. Yes, my dear friend, in this lesson we will learn to control the Raspberry Pi camera with the Python programming language. So let's get started without wasting any time. For this, let's open the VNC viewer and let's connect our Raspberry Pi computer. So here is our IP address, so now let's connect this. And also, if you want to control the Raspberry Pi camera with Python programming language, in order to do this, we need to learn a new module. The name of this module is the Pi camera module. We will use our camera connected to the CSI port with this module, especially in order to be able to do image processing projects in the future. We need to learn this module well, because this module will make our work easier. So let's continue. Let's open the terminal. And also, let's open our Visual Studio Code IDE. For this, let's type here code and let's press enter. And also, let's move to our project folder and let's create a new Python file. Here, let the Python file name be this time image processing underscore 6.py. And also, let's press enter. Alright, if you want to control the Raspberry Pi camera with the Python programming language, we should import a new module here. The name of this module is Pi camera module. So now let's import Pi camera module. And also let's use this module as, for example, cam. And also let's mutate new line and let's call here select module. Because when we give a waiting time, our camera opens more easily and performs the operations. That's why we need to import select module here. So let's import select module. And also let's use this module as, for example, letter S. And we are done. So now let's mutate new line. And in this new line we will learn a new class. With this class we can successfully reach the camera object, which is on the CSI port. The name of this class is Pi camera. If you want to use Pi camera class, what we have to do now is to create a new object here. For example, let the object name be camera. And also you can use different name and put an equal sign and let's call cam dot. So why did I type here cam? Because we are using Pi camera as cam. And put a dot and let's call here Pi camera. And also open and close parentheses, and in the parentheses we didn't enter any parameter. So we are done. And also let's mutate a new line. Of course, capturing images on the terminal is quite simple. However, we need to do extra work here. This is to adjust the image size. For this process, we need to set the resolution parameter in our camera object. For this, first let's call here our camera object and put a dot and let's call here resolution. And also put an equal sign, and if you want to set our image size using camera object, we need to create a new tuple here, and in the tuple we will enter two different values. The first value is representing our width, and the second value is representing our height. For example, let the width value be 640, and put a comma. Let the height value be, for example, 480. Alright, we are done. So now, if you run our code like this, alright, we got an error. It's about our modern name, not sleep. This is time module. And also let's use time module as T. So sorry for this. And if we run our code again, and you see here we didn't get any error. So let's continue. Now we need to open our camera. For this, we need to learn a new method. This method is called Start Preview. This method will open our camera and provide images so that we can save image. For this, let's mutate a new line. And also, if you want to learn a new method, which is Start Preview methods, what we have to do now is to call here first our camera object. And also put a dot, and let's call here start underscore preview method, and also open and close parentheses. And we are done. And as you know, we have already imported our time module, because when we give some reaction time to our camera opens more easily and performs the operation. So that's why let's mutate new line, and we should give some reaction time for opening camera. And as you know, we will use the time module for this operation. So let's call here t.sleep function. And also open and close parentheses, and for example, let's wait for 2 seconds. And we are done. So now, if we run our code like this, and you see here we didn't get any output. So why? Because if you want to save any image using PyCamera module, we should learn a new method here. The name of this method is capture method. For this, let's mutate new line, and let's call here camera dot capture, and also open and close parentheses. In the parentheses, we will enter one parameter here, and this parameter will be the file name of the image we get. So for this, let's create double quotes, because this type will be sitting. And for example, let the file name be, for example, room.gpg. And we are done. If we run our code like this, and you see here we got an output, so here is our output. For example, let's open our new image, which is room. And you see here we got the output like this. For example, if we change the size of our image, and as you know, if you want to do this operation, let's move to the resolution parameter. And for example, let the width value be 1280 by 720. And let's run our code again, and also before doing this operation, let's change the file name as room1.gpg. And let's run our code again. And you see here we have successfully captured a new image, which is room 1. And let's open this. Alright. So here is our bigger image that we captured. So here is the result. This is our first image that we captured. And also this is our second image that we captured. Yes, my dear friend, in this lesson we used the Raspberry Pi camera with the Python programming language. So now let's continue with our other lessons and learn the PyCamera module in a better way. Yes, my dear friend, in this lesson we will learn how to use the Raspberry Pi camera as a webcam. As you know, we were able to obtain images with the Raspberry Pi camera in our previous 2 lessons. However, if you want to perform image processing projects on a continuous basis, what we need to do is to obtain and display images continuously. So we can think of it like a webcam. The images we obtain over the webcam consist of images that are constantly sequenced one after the other. Now let's write the necessary codes and use our Raspberry Pi camera as a webcam. So let's get started. For this, let's open VNC Viewer and let's connect to the Raspberry Pi computer. So here is our IP address, so now let's connect this. And also, let's open the terminal and let's type here codes. And as you know, this operation for opening Visual Studio Code IDE. And now, let's move to our project folder. And let's create a new Python file here. Let the Python file name be this time image_processing_7.py, and let's press enter. And also let's close this file and these images. And let's continue. If you want to use our Raspberry Pi camera as a webcam, what we have to do now is to import 3 different modules. The first module, as you already learned, which is Pi camera module, because when we import Pi camera module, we will define our camera and perform our necessary definition. So that's why I will import here Pi camera module. So let's import Pi camera module. And also let's use this module as cam. And also let's move to a new line. The other module we will use will convert the images we obtained from the Pi camera class into an array. So which name is import Pi camera.array. And also let's use this module as, for example, AR. And also our last module is OpenCV module. With this module we will display and also we will get output from the image array that we will create. So let's import OpenCV module here and also let's move to a new line. As you know, if you want to use Raspberry Pi camera, what you have to do now is to call our class, which is Pi camera class. If you want to do this operation, first we should create a new camera object here. Let the camera object name be, for example, camera 2. And also put an equal sign and let's call cam.pi camera class. And also open and close parentheses, and also let's move to a new line. So now let's set the width and height value of our camera. As you know, if we want to do this operation, we should use resolution method. For this, let's call here our camera object, which is camera 2. And also put a dot, and let's call resolution. And also put an equal sign, and let's create a new tuple here. And let the width value be, for example, 640. And let the height value be, for example, 480. And we are done. So now let's move to a new line. Now we need to convert the camera object we created into an array. For this, we have to learn a new class. The name of this class is PyRGB array class, and it's defined in the PyCamera.array module. So now, if you want to use PyRGB array class, we should create a new object here. Let the object name be, for example, capturing underscore camera. And also put an equal sign. And let's call AR.HighRGB array class. And also open and close parentheses. In the parentheses, we will answer 2 different parameters here. The first parameter will be our camera object, which is camera 2. And the second parameter will be size of the camera. As you know, our size is equal to 640 by 480. For this, let's create a new tuple here, and let's define as 640 by 480. And we are done. So let's continue. Let's move to a new line. What you have to do now is very simple. We must define the array we obtained in our custom camera method in the for loop. As you know, our images will be sorted continuously. For this reason, we need to operate through the loop. Of course, we need to use a for loop to access the array elements, which is in capturing camera. So for this, let's create a new for loop here. And let the element name be, for example, frame, in, and as you know, if you want to do this operation, we should use the camera object. And also, we should use the special method in the camera object. As you know, our camera object name is camera2, so let's call here camera2 and put a dot. And our special method name is capture underscore continues. So let's call continues. And also open and close parentheses. In the parentheses, we will enter 3 different parameters here. And the first parameter will be array object name, as you know, which is capturing camera. So let's call here capturing camera. And also the second parameter will be our format. For example, RGB or BGR. We will use BGR color format because the OpenCV module is supported as BGR. That's why we will call here format parameter and also put an equal sign, and let's create double quotes here and let's define as BGR. And also the third parameter will be our video port. If I set it as value true here, we will get frames from the CSI port of the camera. So that's why I define as value true here, and we are done. So now put a colon and let's move inside of our for loop. Alright, my dear friend, now we need to assign the value of array in our element variable to a variable so that we can use the images we have obtained with the OpenCV module. Because this assignment operation is a default operation. So for this, let's create a new matrix variable. Here, let the matrix variable name be, for example, img, and also put an equal sign, and let's call here frame dot array. And we are done. If we do something like this, we can successfully call the imshow function, and also with this imshow function, we will display our img matrix. So let's continue. Let's move to a new line. What we have to do now is to call imshow function, and also we will display our img matrix variable. For this, let's call cv2.imshow here, and also open and close parentheses. As you already learned, the first parameter will be our window name. For example, let the window name be webcam. And also the second parameter will be our matrix variable name that we want to display on the screen of the Raspberry Pi computer, which is img. And also let's move to a new line. As you know, we have created an array, which is PyRGB array, so here. And we are getting images from this array. For this reason, we need to replace the images we have obtained with new images. Otherwise, we will get an error and the size of the array will be too large. If we want to solve this problem, we should learn a new method here. The name of this method is truncate method. With this method, we can successfully clear the array. So for this, let's move to a new line. And as you know, our array object name is capturing camera, so let's call here capturing camera objects. And also put a dot, and let's call truncate method. And also open and close parentheses. In the parentheses, we will enter one parameter here, which is 0. If we do something like this, we can successfully clear our images array. So we are done. And finally, let's move to a new line. And as you know, if we want to open any videos or webcam, what we have to do now is to create a condition here, because with this condition we should terminate our code. And let's do this operation now. For this, let's check if I press. So let's call here wait key function, the ESG key for 10 milliseconds, and as you know, our ESG key SQ value is equal to 27. Let's break our code. And we are done. So now let's save our file. And if we run our code like this, alright, we got an error here. So let's check this. Yes. Let's focus now. Here we forgot to call our parameter, so now let's call here use underscore video port. And also put an equal sign. And we are done. So now if we run our code again, and you see here we got the output as we want. And also if I show my hands to the webcam, and you see here, we are done. Alright, my dear friend, in this lesson we learned how to use the Raspberry Pi camera as a webcam. So now let's move on to our other lessons and learn the basics of OpenTV better. Yes, my dear friend, in this lesson we will learn about basic drawing operations. With basic drawing operations, we can draw geometric objects such as lines, circles, and rectangles, and also etc. So, how can we perform these operations? Let's find out now. Let's talk about coordinates before we start. In general, the most important things we need to know is to determine the starting and also ending points. So what do I mean? For example, let's create a new line here. And as you can see here, I have created successfully lines here. And here is the beginning point. And here is the ending point. And as you can see, we created a line between these 2 points, here and also here. It's easy to do this with paint, so what if you wanted to do it with software? Let's find out now. Alright, my dear friend, so now let's connect to the Raspberry Pi computer. So let's open the VNC viewer. And here is our IP address, so now let's connect this. And also, for example, let's use a black image. And also, if you want to download black image, let's open the Google. And let's type here black background. And for example, let's use this image. So let's collect this. And let's right-click. Let's download our new image to the desktop. And let the file name be, for example, black underscore background img. And let's save this file. Alright, so now let's open the terminal. And let's type here codes. And also, let's keep our black background image. And let's drag into our Raspberry Pi projects folder. And you see here, we are done. So now let's move to our project folder. And let's create a new Python file. Here, let the Python file name be, for example, image underscore processing underscore 8.py, and let's press enter. And here is our new Python file. And also, if you want to draw any line using OpenCV module, what we have to do now is to import CV2 module. So let's import CV2 module here, and also let's put a new line, and in this team line we will create a new matrix variable here. In the matrix variable we will define our black background image. So for this, let the matrix variable name be, for example, black, and also put an equal sign, and let's call IamRead function here. Open and close parentheses, and let's create double quotes here. And let's define our file name, which is black background img.gpg file. So let's define black underscore background underscore img.gpg file. And if you run our code like this, and you see here we didn't get any error. So now, if you want to draw a line using OpenCV module, we should learn a new function here. The name of this function is line function. If you want to use line function, let's call CV2.line function here, and also open and close parentheses. In the parentheses, we will enter 5 different parameters here. The first parameter here will be the image matrix variable name that I'm going to draw the line from. As you know, which is black, so let's define black matrix variable here and also put a comma. And the second parameter will be our starting point. And if you want to define our starting point, we need to create a new tuple here. The first parameter will be our x-axis. For example, let the x value be 100. And the second parameter will be our y-axis. And let the y-axis be, for example, 50. And also put a comma. Again, the third parameter will be our ending point. For example, let's set it as 500 by 450. And also our fourth parameter will be the color. If you want to set the color of the line, we should create a new tuple here. And in the tuple, we will define 3 different parameters. The first parameter will be our blue intensity. The second parameter will be our green intensity, and the last parameter will be our red intensity, and the value we enter it here must be between 0 and 255. For example, if I set it as 255, 0, we will draw the blue line, but otherwise, if I set it as all of the intensity 255, we can draw the white line. For example, let's draw a white line here, and also the last parameter will be our thickness. For example, let the thickness value be value 5. Alright, we are done. So now let's display our black image. For this, as you know, we should call here IamShow function, and let the window name be, for example, black. And let's display our black matrix variable here. And also, not limited to this, let's call waitK function because we want to keep our window continuously. And let's call waitK function, and let's define value 0 here. Alright, we are done. So now, if you run our code like this, and you see here, we have successfully drawn a white line to the black image. For example, let's change the color. Let's define as 255 by 0 by 0. And if you run our code like this, and you see here, we got the output blue line. So we are done. And also, if I change the thickness of the line, for example, if I set it as value 10 here, and if you run our code again, and you see here we have a bigger line. So here is the result. Alright, my dear friends, in this lesson we learned how to draw a line using OpenCV module. So now let's move on to our other lessons and learn the basics of image processing better. Yes, my dear friend. In this lesson, we will learn how to draw a circle using the OpenCV module. Let's talk about the circle before we start drawing. If you want to draw a circle, we need to define the radius information and of course the center point information in the function we will use. As you can see, our red dot is the point center of our circle. And also our green line is the radius of our circle. If we define these two parameters, center point and also radius, we can create a circle easily. So let's learn how to draw a circle using the OpenCV module. Let's get started. Alright, so now let's connect to the Raspberry Pi computer. So let's open the VNC Viewer and here is our IP address, so now let's connect this. And also, if you want to draw a circle, let's open the Visual Studio Code IDE. So let's type here code. And let's move to our Raspberry Pi projects folder. And let's create a new Python file. Here let the Python file name be image processing _9.py and let's press enter. Alright, so now if you want to draw a circle, what you have to do now is to import OpenCV module, which is CV2 module. So let's import CV2 module here. And also, let's draw a circle on our background's img.jpg image. So for this, we need to create a new matrix variable. Here, for example, let the matrix variable name be circle_img. And also, let's call img function. And let's read our black underscore background underscore img.jpg file. And also, if we want to draw a circle, we need to learn a new function here. The name of this function is circle function. So let's call here cv2.circle. And also open and close parentheses. In the parentheses, we will enter 5 different parameters here. The first parameter will be our output matrix. As you know, this is circle underscore img matrix variable, and also put a comma. At the second parameter will be our center point. For example, let the center point be, and also it must be in the top hole. So, for example, let the center point be 150 by 250. And also, the first value of the top hole is representing the x value of the center point, and also the second value of the top hole is representing the y-axis of the center point. And also let's put a comma. Alright, the third parameter will be radius, and also the radius is in pixels. For example, let the radius be 50 pixels, and also put a comma again. And the third parameter will be our color. For example, let the color be this time green. If you want to draw a green circle, let's set it as 0,255,0. And also the last parameter will be our thickness. For example, let the thickness value be value 10. And we are done. So now let's display our circle underscore img matrix variable. As you know, if you want to do this operation, let's call imshow function. And let the window name be, for example, circle. And let's display our circle underscore img matrix variable. And also not limited to this, that's called here weight function. And let's define the first parameter as value 0 because we want to display our circle window continuously. All right, my dear friend, we are done. So now, if we run our code like this, and you see here, we have successfully drawn a circle. And here is the result. For example, let's change the color. Let the color be this time, for example, red. And also, if we want to set it as red, let's define as 0, 0, 255. And for example, let's change the radius now as 100. And if we do something like this, we will draw a bigger circle. For example, let's check our code now. So I will run my code again. And you see here, we have a bigger red circle. So here is the result. Alright, my dear friend, in this lesson we learned how to draw a circle using OpenCV module. So now let's move on to our other lessons and learn the basics of image processing better. Yes, my dear friend, in this lesson we will learn how to draw a rectangle with OpenCV module. It is important that we can draw a rectangle because we will show the object that we will detect in our next lesson in a rectangle. First of all, we need to know the beginning points and also ending points in order to draw a rectangle. Let's draw a rectangle here. So I will draw a rectangle here. And as you can see, here is the rectangle. Here is the beginning point. And also here is the ending point. If you know that the beginning point and also ending point, we can draw a rectangle successfully. So how can we draw a rectangle using OpenCV? Let's learn about it now. Alright, my dear friends, so now let's connect the Raspberry Pi computer. For this, let's open the VNC Viewer. And here is our IP address, so now let's connect this. And also, what we have to do now is to open Visual Studio Code IDE. For this, let's open the terminal. And let's type here codes. And let's press enter. Alright, my dear friends. So now let's move to our project folder and let's create a new Python file here. Let the Python file name be, this time, image processing underscore 10.py. And also, if we want to draw a rectangle using OpenCV module, we should import CV2 module here. So let's import CV2, and also let's move to a new line. And in this new line, we will read our image that we want to draw a rectangle on this image. For this, let's create a new matrix variable. Here, let the matrix variable name be, for example, rect. And also put an equal sign and let's call imread function here. And let's create double quotes. And as you know, our file name be black underscore background underscore img dot gpg file. And we are done. So now let's move to a new line. In this new line, we should learn a new function here. The name of this function is rectangle function. With this function, we can successfully draw a rectangle using OpenCV module. For this, let's call here CV2 dots rectangle. And also open equals parentheses. In the parentheses, we will enter 5 different parameters here. The first parameter will be the source matrix that we want to draw on this matrix. As you know, this is rect. And the second parameter will be our starting point. And if we want to set the starting point of rectangle, let's create a new tuple here and let the x1 value be, for example, 50, and let the y value of the starting point be, for example, 50 again, and also put a comma again, and the third parameter will be our ending point. For example, let the ending point be 150 by 280. And we are done. So now let's move to the fourth parameter, and our fourth parameter will be our color. For example, let the color be. So let's throw a green rectangle for this. Let's set it as 0,255, 0. And also our last parameter will be the thickness. For example, let the thickness value be value 4. Alright, if you run our code like this, and you see here we didn't get any error. So now let's move to a new line, and in this new line let's display our arithmetic variable using IamShow function. For this let's call here IamShow function, and let the window name be, for example, rectangle, and let's display our arithmetic variable. And also, if we want to display our rectangle window continuously, what we have to do now is to call weightk function here. So let's call here weightk, and let's define the first value of the weightk function as value 0. And we are done. So now let's check our code. And you see here we have successfully drawn a rectangle using OpenCV module. So here is our starting point. So here, and here is our ending point. So we are done. For example, let's change the starting point of the rectangle. So let's change the x value of starting point as 350 by 520. And if we run our code like this, and you see here we have successfully changed the position of the rectangle. So here is the result. And also you can change all of these parameters, anything you want. For example, let's change the thickness value as 10. And if we run our code like this, and you see here, we have a thicker rectangle. So here is the result. Alright, my dear friend, in this lesson we learned how to draw a rectangle using OpenCV module. So now let's move on to our other lessons and learn the basics of image processing better. Yes, my dear friend, in this lesson we will learn how to print text on an image. Actually, doing this operation is quite simple. We just need to learn a new function. The name of this function is putText function. With this putText function, we can successfully print any text on image which we want. So let's do this operation now. Let's get started. For this, let's open VNC Weaver here. And here is our iProd. So now let's connect this. And also we need to open Visual Studio Code IDE for this. Let's move to the menu. And also let's select the programming. And here is our Visual Studio Code IDE. So now let's open this. And you see here it opened. And also let's move to our project folder and let's create a new Python file. Here let the Python file name be, for example, image_processing_11.py. And also let's press enter. And also, if you want to print any tags using OpenCV module, what we have to do now is to import CV2 module here. So let's import CV2 module and also let's move to a new line. And in this new line, we should read our image. And also, on this image, we will write any tags that we want. So for this, let's create a new matrix variable. Here, let the matrix variable name be, for example, texting. And also put an equal sign and let's call IamRead function here. And let's read our black underscore background underscore img dot gpg file. And also let's move to a new line. So now we will learn our new function. If you want to call our live function, let's type here cv2 dot put text. And also open and close parentheses. In the parentheses, we will answer 7 different parameters here. The first parameter will be the output matrix that you want to show our text. As you know, this is texting. So let's type here texting as an first parameter. And also the second parameter will be the text, and also which we want to write. And also, if we want to set the text, we should create double quotes. For example, let's show hello world on our image. And we are done. So now, let's move outside of our double quotes and put a comma again. And the third parameter will be the starting point. And if you want to set the starting point of putText function, let's create tuple here. And for example, let the starting point be 50 by 50. And also, the fourth parameter will be the font. If you want to set the font, we should hold here cv2 dot font. And you see here there are a lot of fonts we can use. For example, let's use the italic. And also put a comma again. And the fifth parameter will be the font scale. And also the font scale means that the size of the putText function. For example, if I set it as value 1, we will get the small size. Otherwise, if I set it as value 3, we will get bigger size than before. So let's define as value 1 right now here. And also the sixth parameter will be the color. For example, let the color be green. If you want to set the color as green, let's set it as 0,255, 0. And also our last parameter will be the thickness. For example, let the thickness value be value 2. And we are done. So now let's display our matrix on our screen. For this, let's call here IamShow function. And let the window name be, for example, texting. And as you know, we will display our texting matrix variable. That's why I will define here texting here. All right. And finally, let's call readK function because we want to keep our matrix on the screen continuously. And let's define value 0 here. All right, my dear friend, we are done. So now, if you run our code like this, and you see here, we have successfully written hello world on our image. So here is the result. For example, if I change the font scale of putText function as value 3, we will get a bigger size of hello world. So let's run our code again. And you see, here is the result. And also, if I change the thickness as, for example, value 5, we will get thicker text. And you see, here is the result. For example, let's change the y-axis of our putText function as, for example, 200. And if we run our code again, and you see, it looks perfect. Alright, my dear friend, in this lesson we learned how to write text on image using OpenCV module. So now let's move on to our other lessons. Yes, my dear friend, we will learn about machine learning in this lesson. First, let's see what is machine learning. My dear friend, machine learning is, we can say that it is computer modeling that gives the estimates obtained by doing mathematical and various statistical operations to any data set as an output. So, what are we going to do in image processing? In image processing, machine learning process is performed depending on positive and negative processes. So, what do we mean by the positive and also negative images? First of all, the positive images is the image to be detected. Negative images are images that do not match the image to be detected. For example, we want to detect a tree image in the code we will create. To introduce these three images, I have to indicate trees as positive images. When we come to the negative image, there must be any image except the tree. For example, a car, a house image, or our negative image can be reproduced with samples like monitor image, air conditioner image, and so on. However, the negative image will definitely not be tree-like object. In other words, I give an example in the positive image. If we detect an oak tree, we should not introduce a pine tree in the negative image. So how is the detection done? Let's know about it now. Yes, my dear friends, in this lesson we will have information about how face detection can be done. Before we start this process, we need to know about hierarchy cascades. So, what is hierarchy cascades? Let's get started. Dear friend, we can inform various recognition operation by using the hierarchy cascades class in OpenCV. Here we use hierarchy cascades with XML. Let me know about XML. My dear friend, XML is a file that holds data. Especially when we are going to make a project with XML in machine learning lessons, we keep various data such as coordinate information and detection operations in the binary image we created in it. For example, here it says high cascade eye. So what it means here is this. Is there an eye picture on our image or not? If there is an eye, if we use XML, it will detect our eye inside our face after entering various parameters. For example, when you look at it here, it says high cascades frontal cat face. It means the cat's face, but since it says frontal here, it must have been taken from the front of his face. So we can tick off it like a selfie. Look, it says frontal face default. As you can see here, frontal face default. Here we can introduce our own face using XML file. For example, look here, it says full body. What do we mean by full body? It is an XML file that covers our entire body. For example, it says lower body here. It shows the lower part of our body. And also it says profile face. This is an XML file showing the profile of our face. For example, it says upper body. Here is the upper body. It is the hierarchy cascade file showing the upper body in our body. So how do we perform face detection? Let's learn about it now. Alright, my dear friend, in this lesson we'll learn about hierarchy cascades. So now let's move on to our other lessons and learn how to detect face of people using OpenCV module and using hierarchy cascade class. Yes, my dear friend, in this lesson we will perform face detection with you. Let's get started without wasting any time. For this operation, as you know, we first need the XML file that will perform the detection process. Let's go first and download this. For this, let's open the VNC viewer and let's connect to the Raspberry Pi computer. So here is the IP address, so now I will connect this. And also open the Google. So let's open google.com and let's type here HAR Cascades and let's search this. And here is our web page, which is the second one. So now let's open this. And you see, here is our XML files that we can use easily. And also, if you want to detect face using HAR Cascade class, what we have to do now is to use HAR Cascade frontal face default.xml file. So let's download this now. For this, let's collect the LA Lake. And you see it says it does open series, so now let's open this. Here is our original repository is here, so now let's collect this. And also, let's move to the code. And let's download zip. And you see here, it's downloading. Alright, so now let's open this zip file. And also let's move to the data. And let's collect the HAR Cascade. And here is our face detection XML file. So now let's keep this and let's drop into the desktop. Alright, we are done. So now let's rename it as, for example, face underscore detection. And let's click OK. Alright, my dear friend, so now let's open Visual Studio Code IDE. And also, let's keep this file and drop into our project folder. Alright, so now let's keep this file and let's drop into here. Alright, my dear friend, we are done. So now let's move to our project folder and let's create a new Python file here. Let the Python file name be this time machine underscore learning underscore 1.py and let's press enter. Alright, my dear friend, so now let's do face detection operation. For this we need to import OpenCV module, because we need to reach the HAR Cascade class and also HAR Cascade class is in OpenCV module. For this, let's import CV2 module and also let's move to a new line. And in this team line, we need to create a new variable here and also this variable will be storing our HAR Cascade class. For example, let the variable name be face and also put an equal sign and let's go cv2.cascade. Classifier. And also open envelopes parentheses. In the parentheses we will enter one parameter here and also our one parameter is representing our XML file as a string data type. For this, let's create double quotes and let's define our XML file, which is face underscore detection dot XML file. And we are done. So now let's continue. So now let's move to a new line. And in this team line we need to read our face image. So here is our human.jpg file. We will do face detection on this image. For this, let's read this image. And also, you can find this image on the source section of this video. So, let's create a new matrix variable here. For example, let the matrix variable name be human. And also, let's call imRead function. And let's define our human.jpg file. And we are done. Now what we need to do is to convert our image to gray color format because it's difficult to detect in color images. For this reason, gray colored images are preferred and images in gray color format are single channel. That's why we should use gray color format. So for this, let's create a new matrix variable. Here, let the matrix variable name be, for example, gray. And also put an equal sign and let's call our CV2Color function. Because with this function, we can successfully convert our color images to gray color format images. And as you know, the first parameter will be our input matrix, which is human matrix variable. And the second parameter will be our spatial code for converting gray color formats. Then for this, let's call CV2.color underscore BGR to gray. And we are done. So now let's put a new line. Now we need to reach our coordinates. For this, we will perform the detection process. And also we will learn a new method for this operation. This method is called detect multiscale. And by the way, this method is defined inside our Har Cascade class. And also, if you want to use this method, we should create a new variable here. For example, let the variable name be result. And also, this variable will be storing coordinates of face. And also put an equal sign and let's call face.detect. Multi-scale method and also open and close parentheses. And in this method, we will enter three different parameters here. The first parameter will be our gray color format matrix variable, as you know, which is gray. So let's set it as gray and also put a comma. The second parameter will be scale factor. Basically, the scale factor is used to create your scale pyramid. More explanation, your model has a fixed size defined during training, which is visible in the XML. Instead, this size of the face is detected in the image if present. However, by rescaling the input image, you can resize a large face to a smaller one, making it detectable by the algorithm. It's enough to define 1.1 hair and also put a comma. The third parameter will be minimum neighbors. Parameters specify how many neighbors each candidate rectangle should have to retain it. This parameter will affect the quality of the detected faces. Higher value results in fewer detections but with higher quality. And also between 3 and 6 is a good value for it. For example, let's set it as value 4. And we are done. So now let's move to a new line. Alright, we have successfully detected our face. So now we need to draw a rectangle. Because with this variable we get the coordinate of rectangle. So for this we need to create a for loop here because we need to reach the data from result variable. That's why we need to create for loop here. And also let's call for loop and also we need to define 4 different element variables. And for this let's create a new tuple here. The first value will be x, the second value will be y, and the third value will be width, and the fourth value will be height. And also we need to reach in result. And we are done. And also let's put a colon and let's move inside of our for loop. And as you know, if we want to create a rectangle, what we have to do now is to call rectangle function. For this, let's call cv2.rectangle function. And also open and close parentheses. In the parentheses will be the output matrix. As you know, we did all of these operations with gray color format, right? However, we don't need this matrix variable anymore. That's why we need to work with original image, which is human matrix variable. So let the first parameter be human and also put a comma. And the second parameter will be the starting point. And also, if we want to set the starting point using these element values, we should use x and y coordinates. And also put a comma again, and the third parameter will be the ending point. So let's create a new tuple here. There is something we should pay attention to here. As you know, the ending points represent the x value for the width and the y value for the height. This is why we need to think holistically. So we have to sum the width and x value, and of course, y and height values too. So for this, let's sum x plus width and put a comma, and let's sum y plus height, and we are done. So now let's move to the third parameter. As you know, the third parameter will be the color. Let the color be, for example, this time red. So let's define as 0, 0, 255. And also our last parameter will be the thickness. Let the thickness value be, for example, value 3. Alright, my dear friend, we are done. So now let's display our image on the screen. For this, let's call IamShow function. And let the window name be, for example, face detection. And let's display our human matrix variable. And also, if we want to keep this image continuously, let's call waitK function. And let's define value 0 to the first parameter. Alright, my dear friend, we are done. So now, if we run our code like this, alright, we have an error. Alright, we write wrong class name here because the letter C will be capital. So if we run our code again, and you see here, we have successfully detected the face of this human. So here is the result. It looks perfect. Alright, my dear friend, in this lesson we learned how to detect face of human using OpenCV module and also using HAR Cascade class. So now let's move on to our other lessons and learn the basics of machine learning better.